imagine she is stinky.
Okay, John, you're now live.
Okay.
Okay, John, we're now live.
Okay. Can you hear me all right?
Yes, we're now live.
Okay, well, good morning, everyone, and welcome to the UK Cereal Pathogens Virulence Survey Stakeholder event for 2021. Exactly a year ago, we had a similar meeting, and the reason I remember it vividly, it was the last live meeting I actually attended shortly after we went into the first lockdown. So here we are still in online mode. But we hope, nevertheless, that we can present the results of this year's work and the issues arising. I've got a copy of the programme on one of the later slides. You should have this in your paperwork. There's a few housekeeping issues that I need to talk to you about. My name is John Lucas. I'm originally from Rothamsted Research, Head of Plant Pathology and Microbiology. I'm now an Emeritus Scientist at the Institute. The webinar's due to finish around 1:20 p.m, but we will be having a break at 11:35 for 15 minutes. So hopefully there will be an opportunity to have some refreshments. If you could all stay muted throughout the webinar, that would be helpful. Ensure your laptops are plugged into a mains power source because, of course, the sessions are going on for quite a while. There is a formal question and answer period at the end of the programme, so feel free to ask questions whenever you like. You can do this by opening the questions panel, which should be shown on the right-hand side of the screen. You can also use this to raise any technical issues that might crop up during the webinar. The webinar will be recorded and published on YouTube and the AHDB website if you want to revisit any of the content. You will actually be asked to answer a survey at the end of the webinar. So please, if you could take the time to complete this, this is quite useful so we can improve webinars in the future and other meetings, of course. Presentations can be downloaded in the handout section in the panel on the right of the screen. You can minimize the panel, but selecting the orange box with a white arrow in it, this will make the panel go into the corner of your screen. You can get the panel back by clicking on the orange square again. So hopefully that's all the housekeeping dealt with, and we'll move on to my introduction. Disease surveillance is, of course, a high priority, and I think this year, or past year, ironically, has highlighted this very vividly. It was actually the International Year of Plant Health, but of course the problems were in the human health arena. But I think there are some generic issues around surveillance in terms of the importance of knowing what's happening in human populations and in crop populations. And of course, the Virulence survey is an example of that, endeavouring to understand the dynamics and changes in populations of important cereal pathogens. Of course, here we have yellow rust, one of the main targets of this particular project. And on the right-hand side of the screen there is a view of a rust trial in 2003, courtesy of John West, where you can see a resistant cultivar solstice and what happens when resistance breaks down in the right-hand plot. Now, of course, it's not just yellow rust. We've got here brown rust on the left, septoria in the middle. And on the right-hand side there, we had quite a wet February around the Rothamsted area and fairly warm in places at certain times. And this is a photograph that Bart Fryer took just a few weeks ago, showing active septoria in a wheat field. suggesting that we may well be having issues with that disease already. Now, there are, of course, continuing threats to cereal crop protection. The first is pathogen variation. One good example of that is recombinant populations in yellow rust. We have a much more complex yellow rust population to deal with than we had a few years ago prior to the arrival of recombinant populations in the sexual stage. We, of course, have continuing problems with fungicide resistance. In the QOIs, azoles, and now in this succinic dehydrogenase inhibitors in Septoria. And we've got loss of some key actives, chlorothalonil and epoxiconazole being two examples. This is some data provided by BART that just shows the situation with the SDHIs. The graphs are sensitivity data from populations of Septoria, and you can see a gradual shift towards the right-hand side. The last, most furthest to the right curve is actually the 2020 population. So we are seeing changes in sensitivity to the SDHIs. Fortunately, the mutations that confer the highest degree of resistance are quite rare in the population, with the exception of the one, which is H152R, which appears to be quite prevalent. But it's not all bad news. I think it's true to say that variety resistance is improving. We've got improved background resistance to yellow rust, so perhaps we don't see the spectacular breakdowns that we saw in past years. More Septoria resistant varieties are there in the recommended list, so I think farmers now have a greater degree of choice. And we do have new actives, in spite of the general doom and gloom about what's being happened with availability of different modes of action. We've got some very promising new products, including Revisol. I can't actually pronounce this one, mefentrifluconazole, and Inatrec, which is in the process of being authorized. Now, here's some data just to back up one or two of those things that I said. This is the current recommended list, yellow rust ratings, and you can see that there's quite a lot of 8s and 9s there. So we've got a good amount of resistance in the varieties, but this is no guarantee, of course, that the varieties won't encounter new races and those scores will change. But at least the starting point is quite promising. And this one is Septoria. What I've done here is looked at the variety ratings over a series of years, and you can see that key point, I think, is that in recent years, particularly 2020, which is the dark green columns on the right, there's quite a good number of varieties with 6, 7, and a few at 8, which is something that we didn't really have in the past. So things are heading in the right direction. Now, I think the important thing is to get on to the real business of the meeting. So this is an overview of the programme. As I said, I think you've got this in your paperwork. All I would say about it is we're very pleased that we have 2 guest speakers, as well as the team from NIAB, and also a bit of an international dimension to it, but of course, because of course disease control is an international issue. And at the bottom there, the question and answer panel, where we've got a group of different experts with a range of expertise, both from academia and industry, and people with strong agricultural experience as well. So we'll get back to that when we actually reach the Q&A. So at this point, I'm going to move on to the first presentations, which actually are from the NIAB team. I'm going to introduce the speakers here. Lucy James is the programme lead within the pathology entomology group at NIAB, and she's also lead of the UK cereal pathogen virulence survey, taking over last year. Prior to working at NIAB, Lucy worked for a while at AHDB as a senior scientist. Amelia Hubbard is a plant pathologist within the pathology and entomology group at NIAB. She's currently managing and delivering the technical work of the UKCPVS with a focus on yellow rust. And Sarah Wilderspin joined NIAB in 2016. and she's a research assistant who actually, alongside Amelia and Lucy, is focusing on largely on wheat brown rust and powdery mildew. So anyhow, over to the NIAB team.
Thank you very much, John. I'm just going to hopefully share my presentation. Can you see my slides?
Yes, they're up.
Perfect, thank you. Good morning and welcome to the UKCPVS stakeholder meeting. I'm Lucy James, the project leader of the UKCPVS, and today myself, Amelia Hubbard and Sarah Wilderspin will be presenting the annual UKCPVS results. So just to start the presentation, I'll just give you a brief overview of how our presentation is structured. First of all, I'll be giving some introductory slides, and then I will pass on to my colleague Amelia Hubbard, who will be presenting the wheat yellow rust data. Sarah Wilderspin will then take over and give an overview of the brown rust data, and then we'll head back to Amelia, who will give us a summary of the work she's been doing on the barley powdery mildew and brown rust. So just to introduce the project, I'm sure many people in the audience are aware that the UKCPVS has been in operation since 1967, so more than 50 years. The aims of the project are to identify changes in pathogen populations that may have an adverse effect on cereal production in the UK, and it's our job to report them as soon as possible to provide growers with the most up-to-date information. And this project is jointly funded by AHDB and by AFA. So just to begin, thought I'd give an overview of the processes a sample goes through when it arrives at the UKCPVS labs, because it is quite a lengthy process, and unfortunately we are not able to test every sample that comes in. At the first point where the sample comes into the labs, it's registered on our database, and then a tiny section of the leaf is placed into a solution called RNA later, and this is to preserve it for genetic analysis later on downstream. We will then put the samples into incubation, and after a few days, when it begins to sporulate, we'll then transfer those spores to a susceptible variety ready to bulk up spores. So after a period of around 2 weeks, we'll be able to collect those spores, and we will carry on collecting them over a period of time. And if necessary, we will then repeat the entire process to ensure that we have enough spores for all our experimentation. Once the spores have been multiplied, we will then go on to select around 25 different isolates, and these will then be tested on our seedling differential tests, which I'll be talking more about through my slides. And we aim to have all these tests completed before December after the season is finished. Once this data is available, we're then able to select a further 5 isolates which are representative of the population, and we will then carry out adult plant tests and variety tests. And lastly, all the isolates that have been multiplied we will then put into our long-term storage, and we have many, many isolates which dating right back to the 1970s. So to help us identify changes in the pathogen population, every year farmers, agronomists and RL trial staff send us infected leaf samples of yellow rust, brown rust and mildews, and we test those samples to see if it's new, if it's a new strain of that pathogen or one that we already have seen before. This helps us keep track of the diseases and often gives us the first sign that the pathogens are evolving and adapting to the resistance genes in our UK varieties. So to identify changes in the pathogen populations, we can break it down into a 2-step process. Step 1 is to identify any population change using our differential tests. And step 2 is to identify the risk associated with that change. And we do that by performing adult plant tests and further variety seedling tests with a limited number of isolates. But this time we include the full set of RL and RL candidates. So just to give you a bit more information about how our differential test works, 2 terms that you will hear a lot throughout the coming slides are resistance and susceptibility, and also virulence and avirulence. Varieties are either resistant or susceptible, and the pathogen virulent or avirulent. And our standard differential set consists of varieties with known resistance genes. And here we have just some of the yellow rust differentials listed on the left here with their resistance genes on the right. And if we take the top cultivar, Chinese 166 at the top, it carries the resistance gene YR1. If an isolate infects Chinese 166, it's said to carry the virulence gene for YR1. And that isolate has, the Chinese 166 is said to carry the virulence gene for YR1. And if it's infected, then that resistance has been overcome. So depending on what varieties get infected in the test, it tells us what virulences the isolate carries. We spend a lot of time looking at to identify changes in the population by looking very closely at our test results. On the left-hand side, we have the isolate details. So if you look at the top entry, 16009, it refers to an isolate from the 2016 survey, and the 009 refers to the fact that it was the 9th sample that was received that year. Along the top, we have the differentials and their resistance genes. And then, of course, we have the seedling test results within the bulk of the table. So the tests are scored using a 0 to 4 scale, where values of 2.7 and over show a compatible reaction, and therefore was susceptible. Values of 2.4 to 2.7 are borderline reactions, and anything below 2.4 indicates an incompatible reaction. So if we look at 16184 at the bottom of the table, you can see that it didn't infect any of the YR7 differentials. So we can say it's avirulent on YR7. Before I move on, I'll take a closer look at pathotype and virulence profiles. Pathotype is another name for the virulence profile of an isolate, and we mention it a lot throughout our presentations. It lists the virulence genes that the isolate carries as determined in the differential tests, and also some of the key additional cultivars it infects at seedling stage. Some of these may not have a specific resistance gene associated to them, or they may have additional unknown resistances in their background. So to make things simpler, they're referred to using simple abbreviations of their names. So if we take an example here, the isolate has the following pathotype. It carries virulence for YR1, 2, 3, 4, 6, 7, 9, 17, 25, and 32. But it also infects RE, which stands for rendezvous, SP, which stands for Spalding's prolific, and going along we have Robigus, Solstice, Warrior, and Cadenza. And because the yellow rust population in particular has become very diverse, we've changed the way we name the races to capture this diversity, and also to incorporate any genetic data that we have collected. So we have adopted a naming system which uses colours and numbers. So WYR stands for wheat yellow rust, and the colour in the middle there relates to the genetic group the isolate falls into, and the number on the end is allocated by us to identify the race within each genetic group. So to be able to identify risk of any changes in the rust populations, we carry out adult plant trials during the next season. So we select 5 representative races which are trialled on RL varieties and candidates. Our adult plant trials consist of hand-sown tussock trials, and we run 5 individual trials for yellow rust and 5 for brown rust, which are inoculated with a different isolate. And you can see in the picture here how these are laid out. Each trial has 2 replicates with varieties randomized within each replicate. And we then also put windbreak netting around each of the trials, and that just helps us create a microclimate within the trial to aid rust development. This year, we did make a change to our current method, our normal method. So instead of spraying prior to inoculation in 2020, we inoculated by hand repeatedly through March through till June. These regular repeated inoculations helped us to keep natural infection out, and also to ensure good disease levels. And this successfully increased disease pressure and much improved the data from our 2020 field trials, especially for wheat yellow rust. And as well as the adult plant trials, the 5 isolates are also tested on seedlings of all the recommended list and recommended list candidates. And this data is used to produce the young plant resistance susceptibility tables which together with the adult plant resistance can be found on the AHDB website via the UKCPVS page. We have to look at both seedling and adult plant stages because host resistance can be effective at all growth stages, or it could be effective at just the adult plant stage. So if a variety is, for example, susceptible in our seedling test, it doesn't necessarily mean it will be susceptible at maturity. So really, to get the full picture, we have to look at all growth stages. And that's it for me. So I will pass back to Amelia to carry on with her yellow rust data for this year.
I think I'm muted. Oh, hi. I think I'm muted by the organiser.
You're back on, Amelia, sorry.
Thank you, sorry. I could see that I was muted. So good morning, everyone. My name is Amelia Hubbard and I'm here to present to you the wheat yellow rust report. Just gonna, sorry, having some technical difficulties. I'm sure it's supposed to be. Aha. Right, so firstly, before I start, I'd like to point out the letters in the top right-hand corner of your screens. So for wheat yellow rust, we've got WYR, and then when Sarah is presenting, you'll have WBR. So you'll be able to tell where we are in the presentation at any time. So firstly, a little bit of background for the wheat yellow rust. We had the incursion of the warrior group in 2011, and yet we are still talking about it 10 years on. It's led to this really highly diverse population that we have in the UK today. And then this time last year, we were seeing some changes in 2019 in varietal performance, e.g. for KWS Sciat. And we had more isolates that were identified that were carrying virulence for YR8, Chronic and Crusoe. And we also identified 2 isolates that were avirulent on YR1, avirulent on YR9 and virulent on YR8, and that's a particular combination that hadn't been seen in the UK before, so we were keen to investigate those further in our adult plant tests. And I'm going to start with those adult plant results. So we selected 5 isolates from the 2019 survey to trial in our adult plant tests last year, and we selected these two, 1910 and 19165, so they're the 2 isolates that were avirulent on YR1, avirulent on YR9, but they had virulence for 8. So the top pathotype is similar to a pathotype previously seen in Sweden called the Hereford race, and that's designated as PST S12 by the Global Rust Reference Centre. We also selected 19038 from Chabras. That one was virulent on YR8 and it also infected Chronic seedling stage. So virulence for Chronic isn't that unusual in itself. We have seen it before, but like I said, in 2019 we were seeing a lot more isolates that were able to infect Chronic, so that's why that isolate was selected. We also selected 19119 from KWS Firefly. So back in 2019 we were seeing the first hints of yellow rust on Firefly, so we were keen to look at one of those. And lastly, we selected 19215 from KWS Extase, and that one was selected because not only did it infect Chronic at seedling stage, but it also infected Crusoe, and that we don't see that very often. So here we have just some of the adult plant trial results, and they are expressed in terms of percentage plot area infected, and that's a mean of 5 assessments, all taken after growth stage 55. So we really are just looking at the adult plant results here. And I've colour coded the isolates, so we've got 1910 in blue, 19038 in green, and so on. So the first variety that we're going to look at is KWS Sciat, and you can see that one was susceptible to all 5 isolates at adult plant stage, but it was particularly susceptible to 19215 in that brown colour. And in fact, that score of almost 40% was the highest score, individual score that I saw on an RL variety. Next up, we have KWS Firefly. That one was also susceptible to all 5 isolates at around 10%, but it did have slightly more infection with the 19215 isolate. I've also selected Chabras to show you because that's the host variety for 19038. Higher levels with 19038.
Amelia, I'm very sorry, but you seem to have lost audio. Would you mind possibly going through that slide again?
Oh, yeah, sorry, everyone. So, if we, I don't know how much you heard, but we, KWS Sciat, that one was the highest, the most, sorry, I'll go back to the beginning. So here we have the percentage plot infection, and it's a mean of 5 assessments all taken after growth stage 55. So Sciat was susceptible to all 5 isolates at adult plant stage. You can see it did actually have higher levels of infection with the 19215 trial at almost 40%, and that particular value was the highest I'd seen on any RL variety. Next up, we have KWS Firefly. You can see that one was susceptible to all 5 isolates, but it did have higher levels, again, with the 19215 isolate. I've selected Chabras to show you because that one, it was susceptible to all the isolates at much lower levels, but it was more susceptible to 19038. And also Gleam, that one wasn't a host variety for any of these isolates, but I've selected it because it was particularly susceptible to 19038. It wasn't the only variety to show this, but it was the one that showed the biggest difference between the other isolates. So the next 4 varieties I'd like to show you are Elation, LG Skyscraper, RGT Silver Surfer, and SY Incital. So you can see I've selected these 4 varieties for 2 reasons. One, because they are all more susceptible to 19038 and 19215 in the green and the brown colour, but also because they were more resistant to those 2 Hereford type isolates, 1910 and 19165. You can see LG Skyscraper actually was quite resistant to the 19119 isolate as well. I did find that most of the varieties did show lower levels of infection with that 1910 isolate. So I don't think it posed a particular threat to our UK varieties. The next varieties I'd like to show you are the 2 most susceptible varieties in trials. So these happen to be 2 of our control varieties, Robigus and Reflection. And you can see on the y-axis we've now got a different scale. These were all sort of out between 30 and 50%, with Reflection actually having the highest plot infection in trials at almost 52%. To compare this, I thought I'd show you the most susceptible RL variety, which was Skyfall. So again, we have the slightly lower level of the 1910 isolate, but it did have over 35% with 3 of the isolates. So KW6 stays, that one gets a slide all to itself. And you can see that although the y-axis scale has changed slightly, we've got 15% on KW6 stays with that 19215 isolate. There's a smidge with 19038, but that's just a trace amount, so we would ignore that. It's really that 19215 result that we were interested in. And it was originally sampled from Xstays, and it reinfects Xstays in its adult plant trial. The other variety we were particularly interested in looking at with 19215 is Crusoe. Again, there's a change on the y-axis here You can see it's now very low levels, but there was 2.4% recorded with that 19215 isolate, and that's particularly unusual for Crusoe, and it's actually the highest score I've recorded on Crusoe in UKCPVS trials since Crusoe's been included in trials. There was a smidge this time with 19119, but again, it was just a trace amount. So looking at just 19215, I had a look to see if there were any other isolates that showed this sort of pattern, any other varieties. And there were these three. So Graham, RGT Saki, and LG Prince. You can see they weren't as resistant to the other 4 isolates as Crusoe and Extaze were, but there's definitely more reaction going on with that 19215 isolate. So we had almost 5.5% on LG Prince. So I thought we'd just have a quick look at some of the candidates that I haven't mentioned yet. And instead of doing charts, I've just switched to table form. So if we take the top 2, LG Astronomer and KWS Cranium, these were resistant to those 5 isolates at adult plant stage. So on our assessment key, a score of around 1% is just 2 stripes per leaf. So yeah, they did have a couple of stripes on the plots, but not much. The next group I'd like to look at is Merit, LG Quasar, and LG Illuminate. So you can see these levels, they're starting to creep up now. Merit was the most resistant in that group, but LG Quasar had 11.4% with 19138, and LG Illuminate was 12.2% with 19119. On our assessment key, a score of 10% is all leaves infected, but leaves appear green overall. So levels are just increasing now. So Swallow and RGT Wolverine at the bottom there, they were infected in all 5 trials at 10% or more, with Swallow having 17.7% with the 19038 isolate, and RGT Wolverine had 24.5% with that isolate. And on our assessment key, 25% is leaves half infected, half green. So we are starting to see much higher levels now. So I've got some key points for the adult plant trials. We actually include 70 varieties in each rep of our adult plant trials. So there's a lot of varieties because we also include our controls. So I have only just picked out the varieties that were on the 2020-2021 RL list for the key points. So the most susceptible RL variety in trials was Skyfall, but it was KWS site that saw the single highest plot infection score of that 39.8% with isolate 19215. But there were lots of RL varieties that actually showed very good resistance. Looking at the results, I can see that there were about 10 on the list that all showed under 1% mean score across the season. But I did see lower levels of infection with that Hereford type isolate 1910 for the majority of the isolates. And finally, some RL varieties reacted to just one of the 5 isolates tested, for example, KWS Extaze and Crusoe, and to a lesser extent, we could say that Graham and RGT Saki and LG Print all did with 19215. So next we come on to the variety seedling tests. So these ones are, they mirror the adult plant test and include the full set of RL and RL candidates. So as Lucy explained, we're now looking for scores that are over 2.7 to be classed as susceptible at seedling stage. And you can see the top 3 on the list, Costello, KWS Siskin and Theodore, were resistant to all 5 isolates at seedling stage. Next up is Crusoe and Extaze. They were susceptible to just 19215 at seedling stage, and that's beautifully mirrored in the adult plant results. So the next ones I picked out are LG Detroit, Illicit and Jackal. These 3 varieties are really quite resistant at adult plant stage, but you can see they are not resistant at seedling stage. So LG Detroit was actually susceptible to 19038 and 19215 at seedling stage, and Illicit was resistant to those 2 Hereford types, 1910 and 19165. KWS Jackal, that one's usually very resistant at adult plant stage, but it was susceptible to 4 of the isolates at seedling stage. And lastly, we have At the bottom, KWS Sciat, that one was susceptible to all 5 isolates at seedling stage, but it wasn't the only one to be susceptible to all. So a quick roundup for the variety seedling tests. So again, these are seedling tests conducted on a full set of RL and RL candidates using the 5 isolates from the adult plant trials. I have summarised the results in terms of the 20 varieties that are on the 2020-2021 RL list, because there's actually usually over 96 varieties in these seedling tests, because we also include our controls and the full set of differentials again. So there's a lot of varieties. Just to make things a lot simpler, I've summarised them as follows. So we can say that 18 of the RL and the RL candidates were resistant to all 5 isolates, and there were 9 that were susceptible to all. But if you are interested in seeing the full results, you can check out our UKCPVS annual report for 2020, and that's available on the AHDB website or on the NIAB website if you follow the links for the UKCPVS page. So we're now going to move on to the 2020 samples. So 2020, it was a busy year. I received 306 samples. They came from 25 different counties and 88 varieties. So you can see from the map, the majority of the samples did come from Lincolnshire, but we also had quite a few in from Cambridgeshire and Oxfordshire. We also had samples in from Scotland, from Northern Ireland, and even the Southwest and Wales. So we had a really good geographical spread of samples, and with vast areas of the UK being represented. I would like to thank everyone that did send us in samples during the season, because this was back in March, and basically we were just entering into lockdown 1, and it was such an uncertain time for all of us. I didn't know if we were going to have much of a many samples coming in. So it was great that you were all out there walking crops and sending us in samples. And also a big thank you to everyone who either phoned or emailed me during the season. It was really nice to keep in contact with you. I remember being in the glass house once, and I had a call from an agronomist, and it was a very quiet day at NIAB. I think a lot of people were either working at home or out in the fields, and it was just really nice to speak to somebody from the outside world. So thank you to everyone who kept in touch. So my next slide, it's a busy slide. It just shows how manic that year was. I put on here all 88 varieties. I have colour-coded them, so we've got the varieties that we have between 1 and 4 samples are in green, between 5 and 10 samples are in blue, between 11 and 19 samples, they are in pink. We have Gleam in dark red, we had 20 samples in from Gleam, and bright red is KWS Firefly, because we had 25 samples in from KWS Firefly, and it was the most sampled variety. The keen-eyed amongst you will notice that we had some samples in from very resistant varieties and also some spring wheats. So I just thought we'd have a look at the samples that we did have in according to the rating. So we actually had 86 samples in from varieties rated 9, and the most sampled variety in that group was KWS Firefly with 25 samples. From varieties rated 8, we had 34 samples in, and it was RGT Gravity that was the most sampled with 11 samples. From varieties rated 7, we had 90 samples in altogether, 20 in from Gleam and 14 in from KWS Sciat. From varieties rated 6, we had 10 samples in, all from KWS Kinetic. And from varieties rated 5 or less, we had 15 samples in, and 12 of them came from Skyfall. So the sampling types, we had 59% of samples came just from the RL varieties. These are the RL varieties that are on that 2020-2021 RL list. But we also had 17% of samples came from the candidate varieties. We had 8.5% of variety came in from NL varieties. We don't usually call for NL varieties, but we did have some keen samplers out there last year. So we did get some that were coming up from samples from varieties coming up through national list testing. And we had 15% of samples that came from outclassed or other varieties. So these might be ones that have recently dropped off the recommended list, ones that are being used in research or breeding programs, or also ones that are just control varieties. So good spread of samples were received. So we know 2020 was busy, but just how busy was it? If we go back to 2019 and have a look at the epidemic from 2019, you can see this kind of normal peak where we start getting samples in March and it goes through to June, and in 2019 we had 120 samples in June alone. But if I compare that to 2020, you can see March, started off pretty much the same, but things really started ramping up in April, and I received double the amount of samples that I would do in April compared to the previous year. And then June, my busiest month, we received 160 samples in June alone. And then again, July tails off as normal as the crops begin to snake over. So one question I often get asked is there any difference between the isolates that we get in at the beginning of the season to the ones we get in at the end of the season? And I tested 20001 from Graham, and it was found to have this pathotype here, which is virulence for 1, 2, 3, 4, 6, 7, 9, 17, 25, and 32. But it was also able to infect Spalding's prolific, Robigus, Solstice, and Apache. And then I sampled one of the last ones that came in, which was 2304 from Caddo 6 days, and in its seedling test, it had the additional virulence for Rendezvous, Warrior, Cadenza, Sterling, Cranach, and Crusoe. And just to point out, we had 8 samples in from X days, and they all came in June, but 7 of them all came in the very last few weeks, so sort of like the 26th of June onwards. So it's quite interesting that we had sort of this late flurry of samples coming in from KW 6 days. So from those 306 samples that we had in, I selected 30 for testing. You're probably wondering why I only selected 30 for testing out of 306 samples, but we are actually only funded to test 25, and every year I do end up testing a few more just because it's so hard to whittle it down just to 25. We select our isolates for testing based on sort of host variety, source location, and also any interesting reports that we may have had in during the season with that sample. So you can see I tested 5 samples from Siskin, 3 from Firefly, 3 from Zayat, 2 from Costello, Extaze, Skyscraper, and RGT Saki, and I tested 1 sample from the varieties on the right hand of the slide. So if you have a look at the colours, you can see that I did focus on the varieties that are rated 8 or 9, but I also selected some from varieties rated 7. And we will still be able to go back to our stocks and actually do more testing with all the other samples that came in when we go through our genotyping tests. So now I'd like to show you the seedling test results in terms of percentage virulence frequency. And this is a summary of the last 5 years. So in 2020, virulence for YR 1, 2, 3, 4, 6, 7, 9, 17, 25, and 32 all remained really high in the population and were found in 100% of samples. And that continues the pattern of previous years. It was YR8 we were particularly interested in looking at because that did rise to 17% in 2019, but back in 2020 it dropped back down to around 3%. No virulence was detected for YR5, 10 or 15. I'd like to show you the results from some of the additional cultivars that we included in our tests. So you can see that virulence for Cadenza, Apache and Evolution all rose, with Evolution seeing the biggest difference from 19% in 2019, and it's gone up to 73% of samples in 2020. Virulence for Cranach, that one stayed around 30%, and it follows on from the previous year. Virulence for Crusoe, that one's dropped slightly. It was 10% in 2019, but it's now gone down to about 7% in our 2020 samples. So the most common pathotypes that we found in our 2020 samples. So the 2 most common pathotypes belong to Red 37 and Red 28, and they were found in 17% of the samples that we tested. So we have assigned the race names here according to the pathotype data. Red 37 is a particular pathotype that hasn't been seen in the UKCPVS work before, but it has been identified in work previously done by Christopher Judge, who was here as part of the field pathogenomics project a couple of years ago. So we weren't surprised to see that one. Red 28, that's a pathotype that was first identified in 2017, and it has been seen every year since. So again, nothing new there. Red 27 that was found in 10% of our samples, that one was also first identified in 2017, and it was the most common pathotype in 2018. So again, nothing new there, but we did find some new pathotypes. These are the new ones that we found in our 2020 samples, all at very low frequencies, and they only differ in their ability to infect just one or two different differentials compared to previously existing pathotypes. But the one we were most interested in is this one at the bottom here, because it has virulence for YR8. And I'll be talking about that one next. So when we have a look at the distribution of these new pathotypes, where are they sort of like popping up in the UK? Is there any relation to where they're found? So the first new pathotype, that one came in from firefly, and it was sampled in Lincolnshire. One of the other new pathotypes came in from Cadois barrel from Cambridgeshire. One of the other new pathotypes came in from Cadois cyet from Hampshire. So that pathotype with virulence for YR8 actually came in from Cadois siskin, and it came from Oxfordshire. And we had another new pathotype again from Cadois siskin, and that one came from North Yorkshire. So there's no pattern to where these new pathotypes are springing up in the UK, and that's why it's really important that we still conduct all this sampling across the country so we can cast our net far and wide and try and pick up these new pathotypes. So I'd like to talk a little bit more about the siskin and Costello isolates, because to be quite honest, it's not a name I have to mention very often when it comes to our seedling virulence tests. So we had in 5 samples from Cadois siskin, which I must point out, 2 of them did actually come from the same field, but they were sampled a couple of weeks apart. And we also had 2 samples in from Costello, and both of these varieties are rated 9. And also, we don't actually do any identity checks on the samples that are sent in terms of the variety. So we are relying purely on what the sampler has told us and what they put on the sampling sheet to say that it's that variety that's come from. But I did do further tests with the siskin and Costello isolates, and after 25 days, some sporulation was evident on both siskin and Costello with just a few of the isolates. Sporulation on Cadois siskin was particularly poor, with some very unhappy pustules and lots of chlorotic and necrotic leaves. So this would not be classed as susceptibility in seedling tests, but it is something that has been noted, and 2 of these isolates that were originally sampled from siskin, 20050 and 20191, have both been selected for our 2021 adult plant trials. So the siskin isolates, you can see my little picture there of one of these extra tests that I conducted with it. You can see there's lots of necrosis and lots of chlorosis going on. The leaves don't look particularly happy. We have really low pustulation, so there wasn't actually that much yellow rust on them anyway. And also low sporulation. And I don't know if you can see it well, because I did take these photos with my camera phone, but the pustules from that were on this siskin pot, they're dull, they're flat, they're just not very happy, they don't look very healthy, and this is just clearly not a susceptible reaction. So that's why siskin in our tests is resistant. Next up, I have some information on our firefly samples, because we did get 25 samples in from firefly, and it was quite a hot topic last year. So, but it was resistant in the seedling test that I conducted. So I did quite a lot of work with Cadois firefly. I've done some mini tests using the 2020 Cadois firefly isolates that came in, and I was checking seed stocks to make sure we had the right seed stock of Caterpillar's firefly, but there was no difference there, so that was all okay. And I also did some further work with 2 isolates, 19119 and its re-isolate 2506. So when we talk about a re-isolate, that's just where I've gone to the adult plant trial, because 19119 was one of those adult plant trial isolates, and I've taken a resample from that inoculated field trial. And as you can see, I did actually get some good AIT, which is average infection type weighting of 3 in these separate tests. These pustules are completely different to what we were seeing with those skin isolates. They're fluffy, they're bright yellow, they're happy, they're sporulating. You can knock that pot and you'll have loads of spores come off it. So yeah, we can now class firefly as susceptible at seedling stage. But I have found that it's quite inconsistent, so my hunch is that it might be actually environmentally sensitive. So I will be doing some further work to confirm these results this year, and hopefully working on the new 2021 samples. We get ones in from firefly as well, to have a look at it further, because I do think it's quite interesting how sometimes it's resistant in our seedling tests, and then I can do a completely different test and I can get good infection type weighting. So I'm on the case. So our wheat yellow rust genetic groups, you can see all the samples that we had in last year, they're all sat there waiting in their little RNA later tubes. And you can see the little picture shows that we only need a tiny little segment of leaf in that RNA later, and that will preserve and protect the integrity of the RNA. And we're now, the MARPL pathogenomics technology is being established at NIAB. So the MARPL is mobile and real-time plant disease diagnostics, and that's being set up at NIAB, and we're now running the final optimizations of PCRs before we genotype those outstanding isolates. But unfortunately, we have had a few delays due to COVID-19, just delays in the laboratory, which we should be resolving very soon, and we'll be able to get those results to you as soon as they're ready. So what I can do is go back to our summary slides for the last 6 years, from 2013 to 2018, and show that the red group was the most dominant group in the UK population. The pink group, that's the original warrior race. That one was more common back in 2011 and 2012, but it has declined in the population. The blue group, we haven't seen that one around. It was seen in 2015 and 16, but it hasn't been seen in recent years. And the purple group, that one's usually bumbling along in the background and has been picked up occasionally in recent years. So what I've done is done a pie chart for the 2020 pathotype, but I've assigned the genetic groups using the phenotyping data only, because we just don't have the genotyping results ready for you yet. So you can see what we think is happening is that the majority of the isolates will fall into the red group, and we've got a big chunk there in grey. That's because the novel isolates are currently classified as other until a genetic group can be assigned. And there's a couple of other isolates in there that we are looking at further as well. And no isolates were detected for the blue or the purple groups. So what next?
Amelia, I'm really sorry. If you can hear this, your audio has gone again.
Shall I start that slide again?
Yes, please.
Hi everyone. Right, so these are the isolates we selected for the 2021 adult plant trials. So we've selected 2050, and that one is one of the ones that came in from Caterpillar's siskin. We've selected 20092 from LG Astronomer. It infected chronic patch and evolution at seedling stage, and that pathotype is actually red 37. So we needed to have a look at that because we haven't looked at red 37 yet at adult plant trials. 20191, So that's the Siskin isolate that was virulent on YR8. So we obviously picked that one there. And I've also selected 2293 from KW6 days and 2304 from X days. So they differed in their ability to infect evolution at seedling stage, but they have been selected because of that virulence for Crusoe. So we were keen to have a look at those two further. So the wheat yellow rust, the ratings for 2021-22 have had a little bit of a shake-up, but we still have 54% of varieties with high ratings of 8 or 9. So in the ratings of 9, we've got things like LG Astronomer, we've got Jackal, Theodore. Ratings of 8, we've got Cadius craniums in there. Then for the varieties rated 7, we've now got Fireflies dropped down to a 7, Gravities now a 7. And ratings of 5 in the big orange chunk there. So we've got things like Zaya is now a 5. We've got Gleam in there as well. Ratings of 4, we've got I call them 2Ks, KBS Karen and Kinetic, and Skyfall is now been rated A3. So we'll be particularly interested in looking at those sort of like the ratings of 7 and above to see what those varieties are doing in 2021. So have we seen any rust? Have we had any reports, any samples in yet? Well, yeah, we have. At the time of writing this, we had 6 samples in, but I can say we've now had 9 samples in because some have come in this week. I did actually test 2 of the samples that we had in the autumn. I tested 21003 from LG Skyscraper and 21005 from Skyscraper, and they were found to have those pathotypes there, and they only differed in their ability to infect Warrior, Cadenza and Sterling at seedling stage. So that ends my talk for the yellow rust, but I'd now like to pass you, oh no, sorry, I've got a summary to go through. So as you can see, 2020 was a really busy year. We had 306 samples and some unusual reports. We had some interesting samples from resistant varieties. 1 isolate was identified with virulence for YR8. And we had 2 isolates found with virulence for Crusoe. And the 2 most common pathotypes seen in our 2020 samples were Red 37 and Red 28. So now I can pass you over to my colleague, Sarah Wilderspin, who will take you through the wheat brown rust report.
Hi, just to confirm that's working.
Yep, you're up and running.
Brilliant, thanks. Hi, I'm Sarah and I'm going to present the wheat brown rust results for 2020. A little bit of background information on brown rust. The wheat brown rust surveillance started later than other cereal diseases in 1973. At the start of the survey, there were limited options for the resistant varieties to brown rust, for example, Clement, which carries the LR26 gene. In 2014, the most recent big change saw the brown rust population overcame the moderate resistance in Crusoe. So following on where we last left off at the stakeholders presentation in March 2020, we had selected the 2019 isolates to be tested at adult plant stage, which we then went on to inoculate and assess in the summer. So here are those 5 2019 isolates which were selected to be tested at adult plant stage. They were tested on recommended list varieties and candidates. These isolates were selected for their virulence on KWS firefly at seedling stage, and they also were the 2 dominant pathotypes which infected KWS firefly at seedling stage in 2019, which is highlighted here in both light blue and in dark blue. And 19053 was selected because it had the same pathotype as the dominant, one of the dominant light blue pathotypes, but it also had virulence for LR20. And 19032 was selected because its host variety was on KW's firefly and was the only isolate tested which had virulence for LR24 in 2019. All of these isolates had also come from different counties across the UK. So here are a selection of the adult plant trial results. We have the variety along the bottom and the mean percentage plot infection across 3 weekly assessments for both reps on the y-axis. We've got the 2020-21 RL rating for each variety above each variety in light blue. And each bar represents one of the isolates tested at adult plant stage. We've got 19005 followed by 012, 032, 053 and then 054. You may notice the mean percentage plot infection for these adult plant trials seemed quite low for last year. This was because the brown rust developed quite late in the season, which was towards the end of June, and it didn't have much time to develop before it started to senesce. I believe our windbreak netting may have contributed towards this by creating a slight microclimate, but also across the country, the brown rust developed quite late in the season too. I also inoculated these trials quite a bit more than I did the year before, and they were inoculated fortnightly from March, weekly from April, and twice weekly from mid-May. So looking at Crusoe, this was overall one of the highest infected varieties on the trial and was classified as susceptible, which is to be expected. KWS Firefly had one of the highest infection levels for the isolate 19005 across the trial, and also we can see 19005, 012 and 054 were all susceptible on KWS Firefly, virulent to KWS Firefly, whereas 19032 was avirulent to KWS Firefly. It's interesting to note that 5, 12 and 54 were all, and 32 all came in on KWS Firefly when they were originally sent in, whereas 32 at seedling stage was virulent to KWS Firefly, and 5, 12 and 54 were, 32 was avirulent at seedling stage to KWS Firefly, and 5, 12 and 54 were virulent to KWS Firefly at seedling stage. So why did 19032 come in on KWS Firefly, but in our seedling test and adult plant test was classified as avirulent? Well, it's possible that 19032 sample was sent in, and if it was left in the field, that it wouldn't have developed much further. And if it was in our adult plant test, it would have been classified as resistant. So moving on to LG Astronomer. LG Astronomer was resistant or moderately resistant to 4 out of the 5 isolates tested, which to be expected for its RL rating of a 9. RGT Saki was moderately resistant or resistant to the first 3 isolates and susceptible to the last 2 isolates. And SY Inciter had a bit of a mixed reaction. It was susceptible to the first and last isolates, but then moderately resistant to the second and fourth, and resistant to the middle isolate. Results for all of these adult plant trial results can be found on the UKCPVS stakeholder report on the AHDB website. So moving on to the variety seedling test results. These seedling test results were inoculated with those same 5 2019 isolates as those inoculated in the field on the same set of varieties in environmentally controlled growth rooms. 4 of these isolates were mostly resistant to 4 out of the 5 isolates tested. So Stigomoria carry LR24 and SY Clipper and Theodore were the only 2 RL varieties. There were 2 varieties which were resistant to 5 of the isolates, and this was just Stig and Maris Halberd, Sapo and Maris Halberd. And then most of the other varieties were susceptible to all of the 5 isolates, with the exception of 4 varieties which were susceptible to 4 of the isolates. So if you see any brown rust on SY Clipper or Theodore at seedling stage, please do let us know and send in a sample. So here is a selection of some of the variety seedling stage seedling tests and their respective adult plant test results to see if we can see a link between the 2. And this is just a selection from the isolate 19005. We've got the variety and the 2020-21 RL rating on the left, and then we've got the variety seedling and adult plant results on the right. Red shows that it's susceptible and green shows it's resistant, and then yellow shows it's moderately resistant and orange shows it's moderately susceptible. So for LG Detroit and SY Inciter, they were susceptible to both seedling stage and adult plant stage. LG Prince, LG Skycraper and RGT Quicksilver was susceptible at seedling stage, but was a bit mixed at adult plant stage. We saw that it was moderately resistant, and moderately susceptible. Whereas SY Clipper, Theodore, and Warrior were resistant at both seedling stage and adult plant stage. So this is what we would kind of expect, that we can't predict from what we see at seedling stage to then predict what might happen at adult plant stage. But if at seedling stage you get brown rust on a variety, you can look up and check our results and see how you might expect it to perform at adult plant stage. And if it's got it at seedling stage and it's not shown to normally get it at seedling stage from our results, then it's worth keeping an eye on it to see how it might perform at adult plant stage. So the 2019 wheat brown rust summary. To summarise the variety seedling tests, SY Clipper and Theodore were the only RL varieties to be resistant to 4 out of the 5 isolates. And the adult plant trials, the overall percentage plot infection levels were low, which was most probably due to the season, and there were no major changes in varietal performance. So moving on to the 2020 samples. In 2020, we received 45 samples from 9 counties and 24 varieties. Most of these samples came from Cambridgeshire and Lincolnshire, and overall in 2020, the brown rust levels were quite low. 39 of the samples we received arrived on RL varieties and candidates from the 2020-21 RL list, 5 of which came in from 2019 RL candidates, and the other one was unclassified, which was KWS Coliseum. So here is a timescale of samples received. June means that it's from the 1st to the 15th of June, and mid-June means that it's from the 16th to the 30th of June, and the same respectively for July, except for July goes until the 31st. So in 2019, we received 55 samples. We received a few at the start of the season, which you can see that then went on to peak in June, and then it dropped back down in July, increasing a bit towards the mid to the end of July. And in 2020, we received 45 samples. We didn't receive any samples in 2020 at the start of the season, and we received the first 3 samples in June, on the 2nd, 5th, or 9th of June, and then the rest of all of the samples came in from the 23rd of June. It then peaked in the first 2 weeks of July and dropped right back down to the end of July. So we had this short window where we received all of the samples last year. So this is the first sample which was tested in 2020 and arrived on the 2nd of June on the variety Graham from Lincolnshire. And this is its pathotype. And this is the last sample tested, which arrived on the 22nd of July on the variety KWX stage from Herefordshire and its pathotype. This was also the second most common pathotype in 2019. So the difference between the first and this last pathotype is the first pathotype was virulent on LR20 and LR23, and the last one wasn't, whereas the last one was virulent on LR3A and LR3KA, whereas the first one wasn't. So here are the RL ratings of the samples received in 2020. This is the wheat brown rust RL rating for 2020-21. So we received 6 samples with an RL rating of 3, which came in on Crusoe. One sample came in with an RL rating of 4. So most of all of the samples received had an RL rating of 5, 6, and 7, which is also kind of representative of the fact that the most wheat brown rust varieties have an RL rating of 5, 6, and 7. And we received 5 samples with an RL rating of 8, which either came in on RG2 Saki or LG Prince. And we had those 6 samples which were not on the 2020-21 RL list, those 5 2019 RL candidates and KWS Coliseum. So from those 45 samples we received in 2020, 25 were selected to be tested on a differential test to determine its pathotype. So this graph shows the percentage of those 25 isolates which will carry virulence for the resistant genes, which will pop up along the bottom over a 5-year period. You may notice the year 2016 has been excluded, and this was because this was the year that our Thatcher line resistant genes were added into our differential seedling test, and the environmental conditions hadn't yet been optimised. So for LR1, we can see it's increased over the last 5 years, going up to 100% in 2020. Virulence for LR3A has fluctuated over the last 5 years. Virulence for 17B has remained at 100% for the last 3 years. And virulence for LR20 has dropped quite significantly in the last 2 years. Virulence for LR24 has remained at 0% for the last 3 years. And virulence for LR26 has slowly been increasing since 2015. Virulence for LR28 has continued to increase in 2020, which I'll look into in a bit more in a second. And all isolates tested were virulent for LR37 and Crusoe for the last 3 years. So going back to LR28, I'm just going to take a little look into why has it continued to increase in 2020. So here is a selection of the 2019 and 2020 differential tests at Seedling stage. So last year in 2019, we found that KWS firefly appeared to carry the same resistance as LR28, shown here, and we also found the same, pretty much the same as we did in 2019 in 2020. But we didn't always get 100% agreement, which is shown here, for example, on 20021, which was virulent on LR28, but then avirulent to Robigus, which carries LR28 and KWS firefly. So could this be a possible reason why LR28 is increasing? It could be one possible reason that more KWS firefly was grown in 2020, so more races carrying LR28 were around. However, we only received 3 samples on KWS firefly in 2020, which pathotype carried LR28, compared to 11 samples in 2019. So from our 2020 pathotypes, those which carried LR28 weren't all necessarily coming in on KWS firefly. And we can see here, these are all the pathotypes which carried LR28. They came in on 7 different other varieties. So we can't necessarily link this LR28 increase in 2020 to KWS firefly. There was no specific correlations between these varieties, and nor their locations where they came from. And you might expect the pathotypes for LR to see this increase perhaps by coming from a specific few, but that didn't seem to happen either. We've got these 3 in red are the same pathotypes, and in blue these are the same pathotypes, but all the others were different, with these 4 being new pathotypes identified in 2020. Another possible reason why LR28 may be increasing is that new races may have entered in from another country. Maybe races could have mutated. And also it can be possible that as more KWS firefly was grown in 2019 compared to 2018, that races which carried LR28 may have possibly either continued into or then possibly multiplied into 2020. And so there's just an increase in the amount of races carrying LR28 in 2020. So there are some possible reasons why LR28 could be increasing, and that it can't necessarily be linked to KWS firefly. And also just to bear in mind that the samples we receive come in from all across the country, and then we do just select 25 to be tested, so we get a snapshot of what is out there and what we're testing for. So moving on to the virulence frequencies for the Thatcher line resistant genes, which were added in 2016. As before, we've eliminated the year 2016. So virulence for LR2A has remained at 0% for the last 4 years, and for virulence for LR2B has remained at 0% for the last 3 years. Virulence for LR2C has remained at similar levels in 2020 to 2019, and virulence for LR3BG has dropped in 2020. Virulence for LR3KA has remained at similar levels in 2017 and 2018. And virulence for LR20 has ever so slightly dropped in 2020. All isolates tested infected in the last 3 years infected LR13, LR14A, LR15 and LR17, and for the last 2 years for LR16, and then virulence for LR23 has slowly been dropping. So now on to pathotype frequency. This graph shows the number of isolates each pathotype has as a percentage of isolates tested, and pathotype 1 shows one of the pathotypes identified from the 2020 isolates which were tested. So pathotype 7 was the most dominant pathotype, which had a frequency of 24%, and here is its pathotype. It was followed by pathotype 9, which had a frequency of 12%, and then pathotype 2, 5 and 12. And then all of the pathotypes here only had 1 isolate. You may seem that there is one dominant pathotype, but also there is still quite a high range of pathotypes for brown rust, and there was no correlation found between these pathotypes and their locations. So how many new pathotypes did we identify in 2020? In 2020, we identified 8 new pathotypes out of the 25 isolates tested. They came in on a range of varieties, and 5 of them came in from Cambridgeshire, 2 from Lincolnshire, and 1 from Oxfordshire. The number of new pathotypes identified each year has slowly been decreasing, but I believe this is due to the introduction of those Thatcher line resistant genes in 2016, and they're sort of leveling off to levels which are seen pre-2016 now. Also, brown rust has a clonal but diverse population, so there may be little genetic difference between these isolates. So moving on to the adult plant trials for 2020-21. We have selected 5 2020 isolates to be tested on adult plant stage on recommended list varieties and recommended candidates. These isolates, so 20002 was selected for having a new pathotype in 2020. 20005 was selected because its host variety was from KWS firefly, and it was also a new pathotype in 2020, which had virulence for LR28. 20018 was selected because its host variety was from Crusoe. It was also a new pathotype in 2020, and it had the most complex virulence profile. And 20021 was selected because it was that most common pathotype identified in 2020, and it was the second most common pathotype in 2019. And 20032 was selected because it was the most common pathotype in 2018 and present in 2019 and 2020. The results for these adult plant trial results will be presented in the UKCPVS stakeholders report, which will be around September. So here are the wheat brown rust recommended list ratings for 2021-22. This pie chart shows the percentage of each varieties in each of the RR ratings. So most of the varieties had an RR rating of 5, followed by 6, 8, and 7, and only one variety had an RR rating of 9, which was LG Astronomer, and then only one for an RR rating of 3, which was Crusoe. And there were no varieties that had an RR rating of 4, which reflects SY and Cider RR rating increasing from last year and KWS Lily dropping off the list. So have we received any samples, wheat brown rust samples in 2021? We have received 5 samples on the 30th of November from Oxfordshire and Berkshire, and we expected to see brown rust on these varieties at seedling stage. So to summarise the 2020 wheat brown rust tests, there was moderate to low disease pressure arriving late in the season. The seedling virulence frequencies continued to increase for LR1 and LR28, and decrease for LR20 and remain avirulent to LR24 for the last 3 years, and a common pathotype was detected in 2020. Otherwise, there were no major changes in variety performance from seedling virulence frequencies for 2020 isolates. I will now hand you back to my colleague Amelia.
Hi everyone, I hope you can hear me. So I'm now going to take you through the results for the wheat and barley powdery mildew. So in recent years, there has been some changes to the mildew survey. We are now only testing samples that are sent in to us. We are no longer sampling ourselves from our own field trials, and we are no longer sending out mobile trap nurseries to collect airborne spores in our home areas, which means that in some years we may not have any samples to test. So for 2020, the mildew update is that mildew, it was seen, but it was not accompanied by any reports of varietal problems. We received 2 wheat mildew samples, but neither of those survived incubation. And I had in 1 barley mildew sample, and from that I cultured 6 single positive isolates, and I tested all 6 isolates. So we're now just going to talk about those seedling tests that I did perform for barley powdery mildew. So we had that 1 sample in. It came from Buckinghamshire, and it from the variety Bazooka. And just generally, there was just these really low levels seen in 2020. So the barley powdery mildew
Sorry, Amelia, you've gone again.
I hope you can
Sorry,
still hear
Amelia,
me.
you've lost contact there. Would you mind starting from the beginning for that slide?
Really sorry, everyone. Right, so this is our barley powdery mildew set. You can see we've got some historic varieties on here. We've got some ones that you may not have heard of. And before we were talking about YR genes with the yellow rust, we were talking about LR genes for brown rust, because brown rust's other name is leaf rust. But now we're onto the barley powdery mildew, and we're talking about ML genes. So I have just to show you that the barley powdery mildew differential sets are completely different to what we do for the rusts, in that they're conducted on detached leaf segments, and these are inoculated with a single isolate. We don't perform any adult plant trials with mildew. It's just these differential tests. And you can see my little mock-up of a barley powdery mildew diff set there. So in there, each leaf represents a different variety, and there's actually 4 reps per test. So this would be 1 rep, and then we'd have 4 of those to make up the whole test. The mildew is scored using a 0 to 4 assessment scale, and it's where 0 is no sporulation, no mycelium, and 4 is abundant sporulation and abundant mycelium. So because we've got 4 reps, 2.75 and over is classed as susceptible. So we have a 5-year summary here for the barley powdery mildew results. So virulence for MLH, MLRA, MLG, MLG and CP, and MLA6 were all found in 100% of isolates tested in 2020. Virulence for MLLA, MLA12 and Vanessa, they all declined. You can't see the line for MLA12, but it is there. It's behind the green line for Vanessa. So the ones on this side, they all declined. So virulence for MLA7, MLAB and Optic all declined, and there was actually no isolates showing virulence for Optic in the seedling tests. So the ones on this side, we got virulence for MLK1 in the dark blue, that's in the middle there, that stayed at around 30% of isolates. MLA1 is the bright blue line, that's increased from 25% in 2019, and it's now gone up to 83% of 2020 isolates. Virulence for MLA3, that one's risen to 17% of isolates, and no virulence was detected for Pepino, which follows the pattern of the previous year. So the ones on this side, we have virulence for MLA13 in purple. That one's seen the steepest decline, and it wasn't actually detected in our 2020 seedling tests. Virulence for MLO11 carried by Riviera also wasn't detected. Neither was virulence for MLA9 in blue. But virulence for MLO11 carried by Apex, that one did increase to around 33% of samples. But I must stress these results should be treated with caution, purely due to the very low number of isolates tested. So just to summarise the barley mildew tests, we tested 6 single pustule isolates, all from 1 sample. Virulence for MLH, MLRA, MLG, MLCP and MLA6 was found in 100% of isolates. Virulence for MLA1, that one rose from 25% in 2019 to 83% in 2020. Virulence for MLA3, that one also rose from 0 right up to 17%. No virulence was detected for MLA9, MLO11, carried by Riviera, MLA13, nor for Optic and Pepino. So barley brown rust, we don't talk about barley brown rust very often. So I thought I'd show you what we've been doing with barley brown rust. So it wasn't surveyed as part of the 2020 UKCPVS survey, and it hasn't actually been surveyed since 2009. But in the summer last year, AHDB asked us to include it in 2021 RL inoculated trials. So I went down, had a look at our isolates that we've got in stock, and back in 2009 we were using 2 isolates from 2003 and 2006. So I thought it's about time we actually updated those isolates, and I went out and collected some more new samples. But it was quite late in the season by this year, that time, so I actually couldn't sample from the winter barley trials because they had all senesced, and the spring barley trials were the only ones that were still going out there. So I managed to pick up 3 new isolates from spring barley trials in 2020. And 2 of those have been selected for use in the RL trials this year. So the barley brown rust differential test, again, we've got some historic varieties. You probably won't have heard of many of those. And before we were talking about the ML genes for the mildew, we've now got RPH genes for the barley brown rust, which stands for resistant to Pathogen Powdery. And I've tested 2 of the isolates, and tested 3 of the isolates, but barley brown rust 20002 was found to have virulence for 1, 2, 3, 4, 8, and 10. And the other one that's been selected for RL trials was 20003, and that one was found to have virulence for 1, 2, 3, 4, 6, 8, 9, and 10. If you're interested, the 3rd isolate that wasn't selected was 20001, and it had the same virulence profile as 20003, but I just selected 20003 because it was doing better down in the growth rooms, and it was easier to bulk those spores up. So it does just show that the UKCPVS is really versatile. We can pick up these lesser diseases that aren't currently being surveyed because we have a lot of isolates in stock from the past decades, and we can also have we've got our long-term seed store with many varieties in there, so we can pull out these old varieties and use them for the differential tests. Right, so it's now my job to go through the UKCPVS 2020 summary. So that's everything we've talked about here today. So 2020, it did see changes in the pathogen populations, and we have some new and some interesting isolates that have been identified. And we are looking at these further in terms of our adult plant trials, and we await our genotyping results for wheat yellow rust. So please send in samples when you see the disease. Often if you see it when you go out in the field, you think, oh, I'll go and sample that in a couple of weeks' time. You'll go back out there, you can't find it again, or the disease has gone over. So please just send in samples when you actually see that disease. Unusual foci and epidemics, they could be the first indication of something new. So please keep an eye out. And please do keep us updated on unusual sightings via email or phone. I now actually have just 2 more slides on our sampling instructions. So you can find a copy of our sampling sheet on the AHDB website if you follow the links for the UKCPVS page, and it is also on the NIAB website. So if you can, just fill in the variety, the date, location, and also it's really handy if you could fill in sort of like the severity of attack, so percentage leaf area infected, or even just describe what you're seeing out in the field. Is it really heavy infection or scattered foci throughout your field? A crop's growth stage, that's also really handy. And any notes such as fungicide treatments. It must be noted that fungicide treatments that have been applied prior to you sampling it can affect our ability to recover those isolates back in the lab. But if you let us know if it has been treated, then at least we can have a look at that, and we know to treat those with a little bit more caution. So sampling and postage and packaging instructions. Please place samples directly in a paper envelope. Please do not use polythene bags, because otherwise polythene bags just makes it go a little bit sweaty and mouldy by the time it gets here. The diseases we are surveying are wheat yellow rust, wheat brown rust, and wheat and barley mildew. I know I've just mentioned barley brown rust, but we don't need any samples of that in. And please send your sample along with a copy of the sampling sheet to Free Post UKCPVS. You don't need to put anything else on the envelope, just UKCPVS. But if you did want to use a stamp, please send via first class or next day delivery to UKCPVS, Naya Park Farm, Villa Road in Pington, Cambridgeshire. And that's because myself and my colleague, Sarah Wilderspin, we are now based permanently at Park Farm. So if you send the samples direct to us there, we'll be able to pick up those samples the moment they get here. You can send samples to Huntington Road or our headquarters. It's now 93 Lawrence Weaver Road, but there is a little bit of delay because we do rely on staff members bringing it across to us at Park Farm. So if you can send it to Park Farm, that'd be much appreciated. If you want any further information, we have our annual report on the AHDB website, and of course the recommended lists that AHDB produce, and also more links there for further yellow rust work if you're interested in looking at any of that. And I'd like to thank AHDB and APHA, our funders. I'd also like to thank Judith Smith because she's our hard-working lab assistant. And I'd like to thank the trap nursery providers and of course all our samplers, the trial staff, the breeders, the farmers and agronomists. So thank you everyone. And that's it for me.
Okay. So I hope everyone can hear me.
Yes, we can hear you.
Okay, so I presume that's the end there. I should say first thank you to the presenters for that large amount of data that we've seen, and obviously obtained under less than ideal conditions this year, so we should express our thanks to them for that. There are quite a few questions on the question panel here, which I'm going to select a few from, and we'll carry some over to the question and answer session. I think we've got a couple of minutes before our break. I've got one here from Adrian Newton. Are the KWS Siskin Costello isolates that were not virulent attributable to drought temperature stress effects, causing temporary loss of resistance expression? Who would like to answer that one?
Sorry, John, could you repeat that question, please?
Yeah, it was asked. He's asking about the isolates from KWS Siskin and Costello that were not virulent. The fact that they were not virulent, could it be attributed to drought temperature stress effects causing temporary loss of resistance expression?
Amelia, did you have any thoughts on that from your experiments in the
so the I hope you can hear me, everyone. I'll just you can actually see me. When I do my tests, they're all kept the same. I water them sort of like 3 times a week. I'm even during all these lockdowns, I've been in every day, so it wouldn't be in my seedling test. It's not attributed to any drought stress in there. These plants are lovingly looked after by myself, and I make sure that they're not due to drought.
Okay, thanks very much. There's a related question here from Bill Clark, actually. The yellow rust reaction in seedling tests that Amelia showed on Siskin may be classed as not susceptible in the UKCPVS testing system, but in a field situation, this would trigger fungicide treatment. Is it worth creating a new classification group to accommodate this type of reaction?
That's a good comment. Sorry, Amelia, that's a very good comment, Bill. That is something that we could bear in mind for the UKCPVS at this present time. Obviously, from our experiments that we've carried out so far, it will be considered resistant, but we could think about doing some things differently for a field situation. Amelia, do you have anything else you want to say on that?
No, that's exactly what I would have said.
Okay. We've reached the point now where we were going to take a break. I think we should try and stick to the timetable. So is everyone happy with that? To move on to the break now. We will keep over the questions that haven't been dealt with to the Q&A session afterwards.
Perfect.
Okay. So I've got to move on now to, we've got the 15 minutes duration break, okay? Let's make sure that's right. I don't know why this.
It's a little bit different here, but they will contact.
Mhm.
Yeah.
Okay. So, according to my timepiece here, it's 11:50. In fact, 11:51. I hope everyone can hear me and see me. It's my very pleasant task to introduce our first invited speaker, who is Mogens Solv Muller from University of Aarhus in Denmark. I should say that Mogens has done groundbreaking work mapping the distribution of rusts, not just through Europe, but globally, and has contributed enormous amount to our understanding of the changes in population structure in recent years. And he is the manager of the Global Rust Reference Centre, and I'm very much looking forward to his presentation on coordinated efforts for detection and impact assessment of new rust races in Europe. So over to Mogens.
Thank you very much. Can you hear me?
Yep.
Yeah, okay. Yeah, first of all, thank you very much for inviting me to attend your meeting. It's always a pleasure. As Lucy said, that you started in 1967, and since I started in the mid-80s to do pathogens surveillance, the work at NIAB and at other UK institutions has always been a big inspiration. So, but today I'm going to share with you some of the work we have done in RustWatch, which is related to today's topic. So I'll try and share my screen. Do you see my screen now?
Yes, it's up.
It's up, okay. And then it's presenter mode, okay. So yeah, so RustWatch is a European early warning system for wheat rust diseases. And it is a project which is building on national activities in the European countries. So what we try to offer in RustWatch is on top of what is done in the national labs, national rust labs, as we just heard here from NIAB this morning. So just in brief, we are 24 partners. We have a budget of 5 million euros across 4 years. And we deal with all 3 rusts, the yellow, the brown, and the black stem rust. We are 12 universities and research institutes. We are 5 agricultural advisory services, and then we are 7 industries. What is important to bear in mind is that we are interacting with existing stakeholder networks. So we have these 4 here, the VCU testing, the plant breeders, the ag chem industry, and then the extension services. So these are ongoing networks where we are engaging and of mutual benefit. Another important feature in RustWatch is that we have these case study regions. So in fact, we have 6 now. Germany is also a new case study region. These are regions where we interact in more detail with the stakeholders and the end users, but I'll come back to that later. So here you see the partner countries in dark blue, and then the light blue countries are countries where we have network activities only. So the key features, well, it's the stakeholder-driven early warning system, meaning that the stakeholders are deeply involved. We are representing value chain from plant breeding to end user farmers. And then also we have on board the main rust research and resistance breeding capacity in Europe. Another important feature of the project is that we have developed the concept of shared lab and experimental facilities. This is dealing both with host and pathogen genotyping and phenotyping. We have common field trial sites. We have a common data management information system. And then we are working hard to link pathogen features and dynamics with plant breeding and extension. So trying to translate how is the changing pathogens, how is that giving impact on breeding and extension. And finally, the case study regions, that's where we validate our results and also get feedback. So what I would like to focus on today is 3 different areas relating to pathogen characterization and impact. So first of all, rust sampling across a wider area in Europe beyond where we have the national diagnostic labs. And then I will focus a bit on the alignment of our methodologies and procedures so we can have a common interpretation of results across Europe. And then finally, I will make some words about impact assessment of new rust races at the European scale. So the sampling is a key feature, and as you can see here, we have engaged in a collaboration with the VCU trial sites for winter wheat. So in the upcoming season, we have more than 80 trial sites across Europe, shown by the blue dots here on the European map. At all these sites, we have sown out 7 yellow rust differential lines to help diversifying our sampling. And we also get additional samples from farmers' fields and plant breeding sites. Then the data we get in from these trial sites is also managed by the Wheat Rust Toolbox, which is our data management system. I'll come back to that later. And in the system, we are able to link disease observations, race and genotype results, and the sample origin with respect to the host. So we get samples not from all these sites, but we are offering that all trial sites can submit samples to us. So in the system here, they can submit yellow and stem rust to our lab in Denmark, and they can submit leaf rust to INRA in France. And of course, they can also submit to national labs in the countries where such a lab is present. So the aim here is to allow a rapid diagnosis of new rust races at both a national but also a regional and global context. And then, of course, to secure live samples of new races from all over Europe where they may be detected. So what do we do for alignment? Well, the idea is that what is detected in the national labs should be put together in a European context, and therefore we offer each national lab to submit 5 key isolates per disease per year. To the yellow and stem rust will go to our lab in Denmark, where we'll then do race typing based on incoming spore samples, and then follow up by genotyping. And the same applies for leaf rust, which will be sent to INRA in France. We also do alignment based on DNA sample exchange. This is more according to needs and requests. So for instance, our lab has exchanged DNA samples with the lab in Poland, IHA, JKI in Germany, and INRA in France for the alignment of our genotyping platform based on single sequence repeat markers, SSRs. We have also sent samples to John Innes Center for alignment of the yellow rust genotyping between SSRs and the marble technique, as we just briefly heard. And then, in fact, finally, we also have done a lot of alignment work together with the Zero Disease Lab in the US for alignment of SSRs and SNP markers in stem rust. So all this alignment allows us to put results on common maps. And in 2019, we were in fact able to have also a workshop, which was held in Denmark. And before the workshop, the different labs had submitted samples of yellow rust, and then they were inoculated. And then when it was time for scoring, then all the labs people came to Denmark, and then they did the scoring in common and discussed the results. But due to COVID, we could not do that in 2020 and 2021. So this is just one example of how we then put the results on a common map. What you see here is dots, where each dot represent a genetic group of yellow rust. So in this case here, we have 467 samples from more than 250 locations. And these maps here are generated by our data management system. We term it the Wheat Rust Toolbox. But the maps can be exported to any website and embedded in a local website. You can see here is all interactive. So in fact, you can choose the year, you can choose which continent, you can choose which country you would like to look at. And also you can see here that in fact, you can also select which lab or data from which lab you would like to highlight. So in the present case here, you can see that 3 different labs have contributed to what is shown on this map here. So that's INRA and the lab in Poland and then a lab in Denmark. If you then click on the eye here for the genetic groups here, you can see that we divide the yellow rust in genetic groups based on the SSRs. So far we have from group 0 to up to group 15. And if you then click on the eye here, you will have a pop-up showing which races has been detected in each group, which is represented on the map. So you can see here, in some cases, you will have multiple races within a single group. So this PST0 is representing the former European population up to 2010, before we had the warrior and the Kranich and so on from the Himalayas. And you will notice we have this Brigadier and Rapagoth and Solstice and Tulsa races and so on. The other group, which is now the most common, this is the PSTS10, you see here. So far, we have at least 4 different races. But in the other groups, we have only been detected one or very few races. This map here is, this pop-up is only showing the prevalent races. If you go to this PSTS10, which is the most common at the moment, you will see that we have the 4 races. And if you look at here, the pattern here, this is again showing the virulence with the same system as Emilia showed you before. And you will notice that these 4 races here, in fact, they also share exactly the same virulence phenotype. So that means that we cannot distinguish based on the standard differentials. It's only when we look at how they are differentiated by commercial cultivars we can differentiate those. And this is the naming here is then reflecting cultivars which is showing differentiation. Here is an example how it looked like. So this is only new races within the PSTS10 group. I think this is the one you call red in UK. So here we have 8 isolates from the UK, France, Sweden, the Netherlands, and Denmark, which has been tested first on 10 varieties, and here I only show the results for 4 of them. So you can see here that the original PSTS10 race, which was termed Warrior Minus, is avivalent on these 4 varieties here, Benchmark, KVS Sayat, Kalmar, and Nemo. The former 3 here are all grown in Denmark, and the last one is grown in France. Then in 2017, we detected that the Kalmar cultivar in Denmark showed much higher disease. So there was a breakdown of resistance in Kalmar. And when we had seeds of the Nemo cultivar from France, we could see that they, in fact, they share specificity. So, but the Kalmar race is avivalent on Benchmark and Sayat. Then in 2019, we observed the opposite. We had a new group which was clearly virulent on Benchmark and Sayat and avivalent on Kalmar and Nemo. So that was the 3rd race. And then finally, last year and also the year before, we started to see a new race combining the virulence in all 4 cultivars here. That was then termed Amboise, which is a French cultivar which is grown quite much in France and Belgium, and it caused a lot of trouble on that cultivar. That's why we decided to call it the Amboise race. So this is an example where we have multiple new races emerging within a single genetic group. This is just showing the results from 2020. You see so far we have fewer results on the map. We don't yet have the results from the national lab in France and in Poland and Germany yet. So what you see here is only results produced by our lab in Denmark. And then you can also click, in fact, on to see the race distribution instead of the genotype distribution. So this is an example where you can see the race distribution, and here we also, of course, we have the races detected in the UK. So when you use the map, when you put the mouse on the dots, you will then there's a mouse over, so that will then provide the location name, the cultivar name, and the data provider. Okay, then just to illustrate that these maps and charts, they can be exported to other websites. So this is just an example of how it looks like in Rust Tracker, which is organized by CIMMYT. So where we have a worldwide presentation of results, of Rust results. So, and this is just another type of map where you see frequencies instead of these single dots. And then here you can, again, you can select which years you would like to look at and so on. So in conclusion, on pathogen surveys, I think we have learned that the transnational surveys and stakeholder involvement is essential for wheat rust early warning at the European scale. And especially the collaboration with the VCU and extension services and breeders is highly useful. Then the direct comparison of results between labs and genotyping platforms really require substantial alignment efforts. And this is the basis for being able to put things on the same map. So test or shared isolates and DNA samples, including reference isolates. In the terms of race typing, sharing identical seed of sources or core sets of differentials. And then, of course, regular physical or web workshops to discuss results and new findings. Then I think it's a very important conclusion that the integration between the genotyping and race phenotyping is really necessary. And that's also what I heard from this morning that you are trying to do in the UK. Because this is really needed for giving a deep understanding of pathogen diversity and evolution. And then finally, the wheat rust toolbox, which I have mentioned a couple of times, is really providing the international standard for data sharing and visualization. The toolbox was not developed in this project as such. It is building on a long-term work done by other colleagues at Aarhus University, but it has been further developed in RustWatch. And in fact, we also welcome, of course, results from national programs after alignment, and it is login protected and so on. So quite some labs are using the system to show their own results. Then finally, I would like to say a few words about impact assessment. So as you do in the UK, we also have then set up a series of field nurseries where more than 200 advanced breeding lines and varieties in Europe has been sown at 8 locations, and including this year, it'll be 3 years. And in addition, we have a trial site in Pakistan. So that will then allow then it's usually inoculated with local races at these different locations here. In addition to that, we have a quarantine section in our greenhouse where we can do yellow and stem rust, both seedling and adult plant tests on the quarantine condition. And this is just an example that stem rust can be very harsh also on the European cultivars. So the results from these trials is also managed by the Wheat Rust Toolbox. So, and it is publicly available. So if you go to our website, if you just Google Rust Watch and H 2020, you will come to our website. So in this case here, if you then click on field nurseries, you will then see where the nurseries were located in Europe, a bit about the background, who supplied the seeds and so on. And then there is a panel here which you can click on the pluses here, then you will see a new window. So if you click on the summary, this is just a case where we see the summary, in fact, for seeds provided by NIAP. Again, it's interactive, so you can select which year you want to look at, which trial sites you want to look at, and which seed provider you want to look at. Then this is then based on the simplified disease scale here, going from none up to very high disease. And what you see here, the top left here is the yellow rust situation. So we can see that in fact you are in a very good situation in terms of yellow rust resistance in the material. That's also what we heard earlier this morning. So this is the average figures of these 58 cultivars which were present here across these trial sites. This is how they reacted on average. This is for leaf rust. The situation is not as good, but still it's fair. About half of the varieties were rated with a low incidence of disease. But in terms of stem rust, you can see that we have a very vulnerable situation in case stem rust returns back at epidemic levels. You can see that by far the most of the varieties are either very high or highly susceptible to stem rust. So the stem rust trials were made in Germany and in Sicily, in Italy. In Italy, it was based on natural infection. In Germany, it was based on inoculations, based on stem rust, which has been picked in Germany early on. And then again, you can find all documentation and reports and tools also on the website here. Just click and then you will find the documentation. I think I will finish just by acknowledging all the partners in the consortium. And thanks to all the collaborators who have submitted samples to us. This is from a couple of years ago. And then finally, of course, my team in Denmark. So with these words, I would like to say thank you.
Thank you very much, Mogens, for a very clear presentation. I'm just having a quick look at the question panel. It's quite difficult to read on my computer, so forgive me if I'm taking a bit of time.
Should I stop sharing or how is it?
Sorry?
Should I stop sharing my screen or how is that done?
You can just leave it up for now, thank you.
Okay.
I'm just scrolling down through these questions, and I think at the moment there's none I can see that's specific to your presentation, Mogens. I guess people haven't had time to type them. They may come up, of course, in the Q&A session. Could I just ask a more generic question about the integration of the genotyping and the phenotyping? Obviously, we recognise that as a very important process. Sort of what sort of progress what's the state of progress on that?
In terms of yellow and stem rust, where I have the deepest insight, I think we have a fairly good handle on that. But as I said, since the pathogen population is always evolving into new virulences, so you'll always lag a bit behind in trying to that the genotyping cannot catch the most recent races. I mean, it's unlikely you will ever come to that stage. But the genotyping is helping us a lot to understand the overall or the major groupings and so on. So, and in case you only have a single race or very, very few races, then the genotyping is giving a lot of information already. And just know that the genotyping is going very much faster than the pathotyping. So in principle, all incoming samples will be genotyped in our lab. So it's giving us a first clue of what may be there and if it's something new.
Okay, there's one further one that I can see is pretty specific to you, Mogans. Can you say something about the variety testing being done in Pakistan and why? Are we any further in knowing how the warrior population got into Europe in 2011?
Well, the pathogen population of yellow rust in Pakistan is highly diverse, and in general, I would say that the European varieties do quite well over there. But we don't have the we have the results from the first 2 years, but what is pending is that we try to pick isolates from the European cultivars when they are grown in Pakistan, and then we characterize the isolates afterwards. This last bit is not yet completed. That will then tell us which races may be causing troubles for European varieties.
Okay. Well, that's a very nice presentation, Mogans. I think in view of time, we ought to now move on. Any further questions we can reserve till the QA session. Okay. So I'm just going to remove my question box, which is blocking the screen. Okay, so I've now got the pleasant duty of introducing our next speaker, who is Jonathan Blake. Jonathan is a crop pathologist, but he also has a different hat as a practicing agronomist and farmer. So he's there at the sharp end. He's been with ADAS for 19 years at ADAS Rosemond, and he's also involved in the fungicide AHDB fungicide performance projects. So he can give us some perspective perhaps on the integrated control aspects, which is one of the things I think we'd like to visit during the QA later. So over to you, Jonathan. Sorry, your title is Field Management of Rust in Cereals.
Thank you, John. Can you see my screen?
Yes, we can.
We can.
Thank you. That's great. I'll just put it on full screen now. Fascinating to hear what Morgan's had to say actually regarding the European picture. I can't help feeling pathogens have no respect for political borders, and the more we can do to integrate with Europe and understand what is happening there, the better a picture we will have of what's likely to be happening in our country. Hopefully that's full screen now and you can see my slides. Please let me know if that is not the case. I was asked today to talk about yellow rust control and how we look at that. And I think it would be remiss of me not to look back at 2020 and consider what factors caused the yellow rust that we saw. Because I think, as Amelia alluded to earlier, it was a busy year for yellow rust generally. We had a lot out there in many places, in many cases in places where we wouldn't normally expect it. I'm based over here in Herefordshire, and generally yellow rust isn't a big problem, but we saw it even on some of the higher altitude sites in Herefordshire last year in abundance. I think there were 3 factors that affected yellow rust, the amount of yellow rust we saw last spring. There were the race changes that have already been spoken about. Lucy and Amelia have already dwelled on. I won't say any more about that, but there was also the weather factor and sowing date. And I just wanted to touch on why those might have had an impact. So if we just, I think it's quite instructive actually to look back at what has been done previously on this. And my erstwhile colleague, Pete Ladders, back in 2007, took records from the Cereal Disease Survey. He looked at just under 4,500 records where yellow rust had been recorded over a 15-year period. And he tried to correlate what factors were associated with incidence of yellow rust. And he looked at a whole host. He looked at cultivar resistance, number of sprays, seed treatments, but he also looked at number of frosts below -5 and sowing date. And it was those two that I just wanted to touch on briefly for a moment. Firstly, this was the data that he generated on frosts below -5. And there was a very clear correlation or association between more number of frosts and a decline in yellow rust found. This is in treated crops, mind, at the end of the season. Just 1 to 5 frosts resulted below -5, that is, resulted in a 3-fold reduction in the amount of disease that was seen. And if we had more frosts below -5, 6 to 10, there was a further decrease, again around a 3 or 4-fold step further on. So clearly, frost has a significant impact. Let's just think about last year for a moment, if we may. Unfortunately, we don't have pretty graphs to show exactly or the pattern of frosts below -5, but we do have the air frost data available to us from the Met Office. So this just shows the air frosts in December 19, January 20, and February 20. And you can see quite clearly on the left-hand side, the colours are light blue, generally the lightest shade of blue, between 0.5 and 5 frosts. That said, further east, probably on average closer to 5 to 10 frost days. If we look at the anomaly charts, I'm not going to go into that as well, but that represents roughly something approximating to 5 days less frosts than we would normally expect. But by normal, I mean deviation from the 30-year mean. Look at January, and January was again very mild. We didn't have many air frosts in January, and actually, on average, we had about 5 days across the country. It did vary from one place to the next, but that was about 8 days air frosts less than we would normally expect, and exactly the same sort of a pattern we saw in February. Slightly less air frosts in total, but again, about 8 days less than we would normally expect. So right through from December to end of February, we were seeing less frosts than we would normally expect. And I suspect that probably meant in many places we didn't have frosts below -5 at all. Look at this last winter, the one that we just had, and the picture is much bluer. And we've actually had, I think, a winter closer to average. December, less frosts than we would normally expect, around 5 to 10 days on average across the country. That would be about 4 days less. January went the other way. In fact, we had roughly 15 to 20 days air frosts, and that's actually more than we would normally expect. And February's been about normal. And I've looked at the temperature charts as well. If you look at the anomaly chart for winter 2021, which was December, January, and February, it comes out almost exactly as we would normally expect from the 30-year mean. So we're very close to average, whereas last year, I think we were on average over 2 degrees above average for those 3 months. So it was an exceptional year last year. I think what we're facing this year is something far closer to normal. Another factor that Pete Ladders pulled out from his review was sowing date, and this is for many rather counterintuitive. We usually think that the earlier you sow, the more disease you see. And actually, he found it the other way round. The later sowings, those crops sown through late October, late November, tended to see a greater percent of yellow rust in those, or a greater percentage of the crops sampled in June and July had yellow rust on them. And I think, I mean, he even looked at numbers of sprays, because obviously you might presume that a later sowing like a sprays, he took that out of the equation, so it was a true effect. And I think there's something much more going on here. And I think you know, there's been some talk about adult plant resistance already, but there is, on top of that, it's a very complicated picture, I think, because there is a clear link between age of the plant and susceptibility to yellow rust. And I mean, this is work that Faber and Munt did. It's a very neat little experiment they did under controlled conditions 2 or 3 years ago, where they took, potted up a number of plants, and then they inoculated them in a standard conditions, the same way, at various points after emergence. And they started about 2 months after emergence, finished about 4 months after emergence. And you can see that the plants that they inoculated first, 2 months after emergence, 700 day degrees, had a very high severity. But gradually, as those plants got older, they were inoculating the last emerged leaf in each instance, leaf 1, the level of severity declined, and that wasn't anything to do with the way they were inoculating, they were keeping that standard. And what was even more interesting is that they actually even chose a variety that with no known adult plant resistance. So it wasn't that the plant had genetic predisposition to this, it was just that it was getting older and was naturally developing a greater level of resistance. So there's the genetic side to it, but I think there's also this gradual change that occurs in plants as they develop a greater resistance with age. I've said a bit about what's been and gone and what's happened. I wanted to touch on how we actually control, which is what I was asked to do. I think, in my mind, you know, we're always trying to get from the picture on the left here to the picture on the right. And if we leave it until we've got the picture on the left, there's absolutely no way we can return it to the picture on the right. So there's kind of 3 things I think we need to think about when we're thinking about yellow rust control. Detection. We need to detect early to make sure we're catching it early in the crop and not letting it run. Frequency of application is important, and product rate and use, product and use rate are also a fact. I actually think, I'm going to cover that first, but I think that's possibly the least important of the 3. If we look at the fungicide performance data that we've been generating for many years, this is the most recent data from 2018 to 2020. On the right-hand side, you've got the products with a single mode of action. On the left-hand side, you've got the mixtures. And what you see instantly, actually, is the difference between products is quite small. We test in these trials under quite extreme conditions. We take a highly susceptible variety. In the past, it would have been Reflection. I think last year it was Zulu. And we let the disease run, and then we spray them once around growth stage 33 or 37, early May, and see what effect we have. And when we test in that way, we can pull out differences. And yes, one thing we have almost consistently found over the years, Ignite, the green line there on the right-hand side, is epoxyconazole, and that has been a highly effective tool in controlling yellow rust in recent years. Unfortunately, that is now in a use-up period. It is being withdrawn from market. That said, there are other chemicals out there that still have pretty good activity, and Proline is only a small step behind that. And other modes of action also exist, such as Intrex. And when we look at the mixtures on the left, the differences between them are quite small, but there are some differences. I think it's clear that the likes of a Latacera, a prothioconazole benzodimidine mixture does seem to have a little bit more activity than Ascara and Revistar. Those other SDHI still very good, but not quite as active as that solatinol benzodimidine prothioconazole mixture. So there are some differences. There are some differences in the rates, but generally when we get up to about a half rate of each of those, we're getting pretty good control. One question I'm often asked now, though, we don't test some of the older azoles within this project because we're limited in how many products we can test. But how do the older azoles perform? There are still some around, and tebuconazole is often one. And if Bill Clark's watching this, he'll recognise this slide. It's, I think, one that he drew up quite a few years ago. That shows the activity in eradicant and protectant situations between 2005 and 2007. It's the last time one of the last times we tested Folicure in the yellow rust trials. You can see it right in the middle there, tebuconazole still available and actually performed pretty similarly to Opus. Others in here also doing well. I mean, we said about Proline looking, I think if you're a very discerning eye, you might spot it's not quite as sharp as Folicure perhaps, but still doing a pretty good job at a half label rate. So there are others. I mean, Prosaro, a mixture of tebuconazole and Proline, again, looking very, very strong. And yeah, so I think when we're looking at the azoles and what we can use to control yellow rust, the likes of tebuconazole may be an easy choice. And we've looked at this in the field. We had a small demo of the fungicide performance on the top of the hill in Herefordshire last year, not somewhere you'd normally associate with large amounts of yellow rust, but last year was exceptional in that respect. This was Myriad in mid-June. You can see untreated, it's absolutely stuffed with yellow rust. And we had a number of treatments where we just looked at activity. And this was tebuconazole following repeat applications at growth stage 32 and 37, and just 0.5 of half a dose of tebuconazole was very effective at controlling the yellow rust in there. Other azoles, prothioconazole, I think you can see there's a slight difference there. The left-hand image, a little bit more yellow, and the right, but still a pretty decent job compared to the untreated, and not far behind tebuconazole. Sunol metconazole, if people are interested in that, it equally isn't far from tebuconazole. I'd say it's just between the prothioconazole and the tebuconazole in terms of activity, and we saw that in this demo. The other new azole that's out there at the moment, mefentrifluconazole. This is Myriza as a solo product, but it's better known as Revisol, or one of the key actives in Revistar. It's the new azole that was launched last year, and it clearly has activity on yellow rust. I would put it perhaps closer to Proline though than to epoxyconazole. I don't think it's quite as strong as we would hope, but put that with Imtrex in products like Revistar, and it performs perfectly adequately. So that covers products and rates. I wanted to touch on timings, and I think the starting point to talk about timings on yellow rust is actually to talk about why we have the timings that we do for Septoria control. And this is an extract from the Wheat Disease Management Guide, and it's actually based on data generated in the late 90s using epoxyconazole, and epoxyconazole was working very well on Septoria. And I need to talk you through this because it's quite complicated. Each of these charts represents a different leaf and the control on that leaf. And the bottom chart here represents control on leaf 3. And you can see quite clearly here, if you apply a product at growth stage 32, or leaf 3 emerged, just after that leaf's emerged, you get very good control on leaf 3. You also, from that growth stage 32 application, get quite good control on leaf 2. It's a suboptimal timing on leaf 2. It's before that leaf has fully emerged, but you get probably Septoria somewhere in the order of 60 or 65% control on that emerging leaf. We then usually apply around growth stage 39, and you can see here at the top chart, we get quite good control when we apply products to the flag leaf just after the flag leaf has emerged, probably somewhere in the order of 80 or 90%. And again, it's suboptimal for leaf 2, but because there's only probably a 10-day gap between leaf 2 and the flag leaf emerging, we usually get pretty good control on the leaf 2 as well. And the combined effect of the protectant from T1, the curative from T2, means although we aren't actually applying anything at growth stage 33, 37, we're not applying anything directly to leaf 2 when it's fully emerged, or just after it's fully emerged, we still get pretty good control of septoria. The reason that works is due to the shape of the percent control curves here. They're quite broad, and they're broad because septoria has quite a long latent period. Generally, it's between 15 and 28 days, 15 under ideal conditions. So during May, yes, it probably is quite good conditions. So you might assume somewhere in the order of 20 days. We get quite good control on leaf 2 from the T2 because it is only 10 days after that leaf has fully emerged. It's only halfway through its latent period in the infection that occurred at the point of leaf emergence. So we get that curative activity, and even if we're a little bit early or late with our T1, it probably still works. Problem with the yellow rust is, and others may have a view on this, but as far as I understand it, under ideal conditions, yellow rust can cycle in around 10 days. And those conditions in May are pretty good for yellow rust, so probably quite close to that. And that changes the shape of the curve. Now, we don't have research that's actually looked at this in depth. What I'm about to show you now is what we think may be the case. And just mocked up what I would suspect is probably closer to the case for yellow rust. And you can see a much steeper wave here at all the three timings. And that means that at the T1 timing, when you apply for yellow rust at growth stage 32, you get very good control on leaf 3 in terms of yellow rust. Again, at flag leaf, you get very good control when you apply just after that leaf has emerged. The problem occurs in the middle here. Because the curve is shallower, actually the amount of control that we would see from yellow rust on that yet to emerge leaf 2 is much lower. Equally, the amount of curative activity that we can expect from the treatment applied 10, 12 days after that leaf has emerged is less, because the time is such that, and the latent period is such that the disease has had ample time to cycle and cause problems. Now, it might sound like I'm creating a situation where people panic and think that they need to rush out and make sure they get yellow rust under control. I think in most circumstances, the level of infection early in the season and the variety that we've chosen probably means that we don't have to worry too much. In many circumstances, that T1 and T2 strategy is sufficient. The problem occurs, I think, where we're growing very susceptible varieties and where we've extended the gap between T1 and T2. And the varieties I'd be most worried about are those that I think fall in the categories on the left-hand side of this table. Those that are rated 5 or less for yellow rust are ones where we know that yellow rust can be very active and aggressive. On the right-hand side, as John alluded to earlier, there's a heck of a lot of varieties out there that might see a little bit of yellow rust from time to time in seasons or situations where yellow rust is prevalent, but probably are less prone to yellow rust overall. And assuming yellow rust isn't in that crop at growth stage 32 around that T1 timing, I suspect in these more resistant varieties, that T1, T2 strategy will be ample. I should say the shape of that dose response, or that percent control chart that I just showed, will change with variety as well, or other products. So there may be things we can do with products to guard against that as well. So to summarise on yellow rust control, I think on those varieties rated 5 or below, I think we need to be very careful with these. We need to mind the gap between T1 and T2, and that can be done in 2 ways, I think. Strategic use of an earlier spray around growth stage 30 can prevent infection from getting embedded in the crop prior to that T1 timing. Also, that can help prevent our T1 or our first growth stage 32 spray going early. It's a symptom that often occurs where people are faced with a good spray window the week before we would normally expect that growth stage 32 or leaf 3 to be fully emerged, they go early. And that just extends that gap between T1 and T2 and allows even more chance for yellow rust and septoria to some degree to step in and infect quite an important leaf in leaf 2. We can also we can add an additional treatment. It's not always a preferred route, but there is always that option of applying something specifically for yellow rust control at leaf 2 emerged, and that has been shown to be a very effective way of controlling yellow rust. I think on the other varieties where we're looking at 6s, 7s or above the yellow rust, there are varieties we have to watch in here, and the early warning system that AHDB has on their website, flagging up varieties, is very useful. Anything that can show us varieties that we have to watch, and I note that X-Days and Graham were flagged up as varieties to watch. Any variety in here I think we have to be careful of, but I think the need for additional steps to control yellow rust above and beyond what we're already doing for septoria probably depends very much on the season and situation. I wanted to finish just by saying, this is a precursor to the question and answer session, isn't it? We don't have all the answers. Some of the panel about to join me, I think, may have a view on that themselves. But I think the point I'm trying to make is I think there's a lot we don't know. And I'm in no means belittling the good work of the UKCPVS in this respect. I think what they do is fantastic with the resources that they have. But much of the work that we have is retrospective rather than predictive. And I think the more we could get to being more predictive, the better a place we would be. Because as we try to develop more of an IPM approach, we need to better understand the relationship between pathogen, host, and the environment. And if we can do that, then I think we can give better guidance and advice to growers and be more targeted in our fungicide use. And the more we can target our fungicide use more effectively, well, that has a whole host of benefits, not just from reducing our total load of fungicides being applied, but it also could actually improve our septoria control, and that is by using azoles where we don't need them to control rust. I think there is some of that occurs. If we can identify those places and not apply azoles, then we have an incidental benefit on our septoria control, because those azoles are incidentally, when we're applying them, are selecting the greater insensitivity in the azole group to septoria. So, or selecting septoria that's more insensitive to the azole. So if we can reduce that, then we can both improve our environmental profile, but also improve our septoria management. Just wanted to finish by acknowledging some of the people that would have contributed to this through some of the work they've done that I mentioned. Thank you.
Okay, thank you very much, Jonathan. Could you leave that last slide up, perhaps, the questions one, because that might be useful in the Q&A, that one.
Sure.
Anyhow, thanks very much for the slightly different perspective, bringing in other factors, environmental, sowing date, etc., which I'm sure is all going to be relevant for the further discussion. So I think at this point, rather than specifically taking your questions yet, I should introduce the panel who've been sitting there patiently waiting for their opportunity to comment. So just to introduce them, Jonathan is going to be on the panel, so is Mogens, and in addition, we have Mike Shaw, who's just appeared from the University of Reading. Mike is a population plant pathologist, I think, or ecological plant pathologist, I think he likes to describe himself as. We've got Stephen Kildare, who many of you will know from Tagash in Ireland, Carlo, Kerry Maguire, who's with Bayer Crop Science, and who are we missing? Hans, here he is. Right on cue, Hans Kuhls from Magenta, where he is, as far as I know, head of fungicide bioscience. I think they change the titles of these jobs a bit from time to time, so I hope that's still correct. Is it, Hans?
Yes.
Good. Okay, now I haven't looked at all the questions in the panel because unfortunately when I put it up, it blanks out most of the rest of the screen. So I think what I'm going to do is start with those ones that we have already on Jonathan's slide there, or at least some of them. But I'd also like to comment that any member of the panel who would like to comment on some of the things that they've heard so far, I think we should give them the opportunity to do that. So I'll start with that. If there's any burning issues that our panel members feel have come out of this set of presentations, perhaps we ought to consider those immediately. No questions there? Well, I'm going to jump in then. There's one here that actually was provided ahead of the meeting. How can you decide not to spray considering adult resistance operates after T2? I think that's one that Jonathan might have a view on.
I think it depends what variety you're looking at, doesn't it? If we're looking at a very susceptible variety or a variety with a lot of yellow rust pre-T2, I'm not sure. This is again comes back to some of the questions I've been raising. I'm not sure we know that adult plant resistance kicks in after T2. But I think the question probably is getting at the person asking that question is getting at is what do you do in a situation where you're looking at a variety that has a lot of yellow rust at growth stage 30 or 32? How do we manage that? We can't sit back and assume, can we, that adult plant resistance will kick in and therefore that variety and crop is safe, because if adult plant resistance doesn't kick in quickly enough, then we will have lost half the green leaf area and a significant proportion of yield. And that's a very fair point. I think until we have greater confidence exactly when adult plant resistance does kick in, and we have to guard against that. And yeah, I think on those situations where we have got yellow rust at those timings, I think it is absolutely right to try and control that chemically.
Okay, thanks very much. That does actually address one of the questions on your slide as well. Adult plant resistance start. The issue of temperature sensitivity, are newer races more high temperature tolerant? That was another one that I'd actually got on my list. Obviously, there's been publications suggesting that we have more heat tolerant yellow rust. You've also brought in the issue of frost tolerance. This obviously makes a kind of quite complex environmental situation, but do we have any direct evidence that the new races invading the UK, for instance, are more temperature tolerant, higher temperature tolerant than previously?
Well, maybe I can comment on that. Well, previously we have seen that some of the new races which wiped out wheat in North America and Australia and so on, they were adapted to higher temperatures. But so far, what I have seen is that the warrior race, for instance, is not more adapted to temperature than others. It's just more aggressive in general at all temperatures.
Okay. I've got another one here which was provided ahead of the meeting, and in a minute I'm going to open the question panel and have a look at what we got. How important is juvenile yellow rust resistance, and how does it impact on T0 decisions? We've seen from the data presented this morning that there are big differences at the juvenile stage, although I think we don't call them juvenile anymore. I think there was a suggestion we should call it young plant.
Was that one for me, John?
I'm not quite sure who it should be for, to be honest. It's a sort of fairly general question, like some of the others I've been choosing.
I'm afraid I missed the very first part of your question, which meant I completely lost the meaning. I don't suppose you'd mind just sharing that again, would you?
It was, well, we've been talking about the early stages of resistance in the growth of the plant. How important is juvenile yellow rust resistance? And how does that impact on T0 decisions? So, you know, a very early fungicide spray, I mean, Jonathan's been talking about the issues of spray timing and how it's a compromise between the different diseases you're trying to control. But specifically for yellow rust, the resistance at the young seedling stage, perhaps, how does that influence decisions on T0 control?
John, if I might maybe just comment, I suppose one of the questions I would have is, okay, it might be susceptible, but is there disease present in the crop or in the local environment? And those sort of questions probably should be the first asked. If there's no disease, there's nothing present, would it be a case that actually is it required just because it has a badge of susceptibility? Now, the argument would be that the exact same case, it might have a badge of resistance, but there might actually be yellow rust present. Does that sort of answer maybe our comment on it?
I think that's a very logical approach, Stephen. It's all part of risk assessment, isn't it? Kerry.
John, if I can just comment on that, I think another way of looking at that is actually what other varieties you've got growing in the area, because although you may feel that the variety that's got yellow rust that you can see at this time, but you're expecting it to end up with adult plant resistance, if that level of disease is going to spread on to neighbouring varieties, then you may actually be setting yourself up for a problem. So I think you have to look at what else you're growing as well, what other varieties, what are their adult plant, seedling, juvenile resistance as well.
Good. So I think we've got a number of contributory factors there in decision taking. I'm just going to look at one more of these ones on the final slide here, and then I'll be checking through the panel, the questions panel, I hasten to add. How can I tell what races have I got in my field? Well, this goes on perhaps back to the question about, you know, rapid diagnostics and are we ever going to have a handheld genotyping system?
I think if you've got yellow rust in your field, you know that it's virulent to the crop that you've got. That's the start of it.
But I think at the early stages, if we're talking about, I presume we're talking about vegetatively juvenile. That's what I've always assumed the distinction is. But at that stage, particularly if you've got a new race, it's going to be a very little patch, and a standard W-shaped walk through the field has actually got very little chance of picking up small patches. And I think you have to prepare your use strategy, your management strategy, on the basis that you're going to have rather poor information about even the presence of yellow rust, let alone what race you've got. For the foreseeable future, I can see how you might do something with drones, hovering over, seeing patches maybe of a few meters and going down to see what they're like. But at the early stages of yellow rust, there won't be anything to distinguish from 100 meters up.
Just a comment from a sort of technology point of view, and whether the technology exists sort of irrespective of the disease that you're detecting, whether you can detect diseases, populations, subpopulations quickly and easily in fields now. I think the technology is not far off, and certainly sort of predicting the next sort of 5 years, we'd start to see that being used on site on farmers' fields. Will that inform spray at this point? When people spray, I'm not sure we're there yet, but from a technological point of view, we're in the realms of the possible rather than the sort of the future, I think.
Thank you, Hans. I'm just scrolling through these questions at the moment. There's one question here from David Ellerton on new chemistry in the pipeline. That's a more generic issue. We've heard about losing actives, but and a couple of new ones, but particularly with reference to yellow rust control, but I guess it should be relevant to integrated control of cereal diseases in general. Is there any further update on novel chemistry in the pipeline?
Who's that to?
Well, obviously, those who are working in the ag chem sector might have comments on this. I know that.
Well, I think sorry, John. I think you gave some examples of some really exciting chemistry that's on the way already with new triazoles, with methane, and the new picolinamides coming on to onto the market as well with the Corteva compounds. So I think that there's going to be a toolbox available to control rusts and other cereal diseases, and certainly sort of regardless, I think, of the regulatory environment. I think synthetic chemistry will remain a priority for controlling of cereal diseases, including the rusts. So I'd say that there's a decent toolbox there already, and certainly we're investing on keeping that toolbox as full as possible.
Okay, thanks very much, Hans. I'm just having a look down here. There's one more yellow rust here. A lot of varieties that were carrying yellow rust before Christmas now appear clean. However, when viewed under magnification, there appears to be high numbers of Telia spores. Is this normal for this time of year? What's the significance in terms of development of new races? So that's directed really to those who are working on the yellow rust issues.
Maybe I can comment on that. Some of the new races, in fact, are more easy to develop Telia than others. So for instance, the warrior race and the carnic race, and there's another new one, which I don't know if you have in UK, they just produce Telia right away from the seedling stage, even in the greenhouse. Whereas the old races we knew from before 2010, I mean, they rarely developed a lot of Telia. So there's a genetic component in it, and often we see that isolates or races which have a near sexual origin somewhere in the world, I mean, they more readily produce Telia than others.
Thank you, Mogans. That's obviously one of the factors that has complicated the whole epidemiology of this particular pathogen.
I think, John, just to comment on that, I mean, looking out at field trials in recent years, I think Telia spores are becoming far more obvious to people. I know from my experience, I'm being sent pictures from our field trials team saying, you know, what's this on the leaves? Because people just haven't seen it. So it's definitely something that is becoming more frequently seen, which is quite interesting.
Now, last year at this equivalent meeting, we had quite a lot of comment on black stem rust and the kind of potential threat this might pose to not just European agriculture, but maybe the UK as well. And I thought with Mogan's comments about the susceptibility of a lot of our current varieties, is there any update on that particular scenario?
Well, I can say that we are also working on black stem rust in Rustwatch, and we have seen pockets in different parts of Europe where we have huge diversity. For instance, in Sweden, and also in parts of Spain, which is nearby barberry. And in fact, also we had some barberry samples from the UK sent in this year, which we were able to recover on both barley and wheat. but whether they will turn into epidemics, I mean, nobody knows yet. But stem rust is a prefer warmer temperatures and so on. And I think so far we've been rescued that the general level of inoculum is very low for stem rust in Northern and Western Europe. But I mean, Stephen, you sent a few samples from Ireland to our lab, and in fact, that was genotyped, and we could see that it was exactly the same as we had seen a few places in France and in Spain. So stem rust is just lurking around, and without turning into big epidemics, at least in Northern Europe so far.
Okay, so surveillance again is going to be important. There's a big question here from Tim Donovan, which is back to yellow rust. Can you explain how agronomists should assess for wheat yellow rust in a variety with known good adult resistance but known susceptibility at the juvenile stage? I'm looking for a robust decision tree or rules of thumb. In Ireland, yellow rust is becoming a more frequent problem, but treating it with a triazole before leaf 3 is fully expanded, i.e. T0 or T1, reduces the efficacy of triazoles to control septoria from growth stage 33 to 60. I think actually that Jonathan's touched on this in his talk already. Any further comments from anyone?
Yeah, I suppose I better add, saying that Tim's coming from an Irish perspective. For us, it is a concern in that, look, we will be battling septoria as a wet weather disease coming later on. And the question we would have is that azole, look, we can look at the dose response that Jonathan presents, and the azoles are providing the most efficacy against yellow rust. But we do know that we rely on the azoles as the backbone of septoria control. So it is a question for us, and that question really is that adult plant resistance, in that how far can we let a yellow rust epidemic in seedlings run before we have to intervene with an azole, knowing that we require that azole for septoria? And is it a balancing act between stopping the yellow rust and impacting our septoria, or is there a happy medium in between? Ideally, we would look and say, okay, if you don't have to use that azole, is there an alternative there? And previously, look, we have recommended the morpholine with a strobilurine in that sort of scenario. I suppose the morpholine we were using is now off the market, so we are going to be looking back and saying, okay, we need a lot of curativity potentially there, so we are going to look at an azole. And it does come back to that case of adult plant resistance. Is there a scenario where we can say, okay, adult plant resistance will kick in and we won't have an impact on the upper canopy? But it will be a case that actually we produce so much inoculum that we'll actually start having scarring, even though we won't get the development of the disease per se. We get a lot of scarring and loss of green leaf area on the upper canopy. So even though we have adult plant resistance, we're still going to lose green leaf area. And I'll be honest, it's a difficult question we're sort of answering at the moment over here, because we do have epidemics of yellow rust developing. And some of them we assume we will require that early application, that T0, that end of tillering azole, knowing that potentially we could impact the efficacy of septoria control later.
Thank you, Stephen. There's one here on early season yellow rust control, again from Bill Clark. You need to be careful about recommending straight tebuconazole pre-T0, as many labels exclude its use at this time. Equally, all strobilurine labels state that they must be used in mixture, so technically it's illegal to use on their own. Further loss of actives is making such decisions more difficult. So there's a bit of a conundrum. I don't know. I don't have the qualifications to comment on that, but does anyone on the panel have something to say?
Bill is right in that certainly some versions of tebuconazole do. I think that you're allowed to apply some from growth stage 30. Please do check though. I'm confident when I last checked 3 or 4 weeks ago, there are some out there that don't have that restriction. So yes, that is true. You have to watch what product you're using to make sure you're staying within the regulation.
Okay, so there's now a breeder's type of question. How likely is it a variety with a very yellow rust susceptible parent will break down to rust itself? Is this a predisposition issue, I presume, is the essence of that question. Do we have any research on this, any data on this kind of thing? I think the silence indicates that we don't have a rational explanation for whether a rust susceptible parent will automatically affect the susceptibility of varieties bred from it. I'm scanning up through these general questions here now. So this one's very specific. It's about that isolate 19215. Do you know at what stage in the season we tend to see 19215? Does Jonathan think that the work done by Peter Gladders 14 years ago may have altered with the new races of yellow rust, as we appear to have seen more frost this season? So this is going back to your frost data.
Yeah, I'm not sure whether anybody else has a perspective from 19215 and why that might be different.
Okay.
If anybody else would like to comment on that, but if not, I'd just say, yeah, it would be interesting to know whether different races respond differently in that respect. And yeah, I think it's another area that, yeah, we don't have an answer to at this stage. I wish we did. Yeah.
Okay, one other specific,
say
perhaps we could go on to thinking about more generic crop protection issues. There's something here about bar
John,
flop.
I think Mike had a view on that last question that he wanted to share.
Oh, sorry, Mike.
Right. Well, it was the question before, actually, about inheriting susceptibility. I think isn't it going to, I may be wrong, but isn't it going to depend on whether you're talking about background polygenic resistance, in which case, if you start from something that is susceptible, the offspring are likely to carry it over because almost everything is some degree of heritability. If you're talking about major gene resistance, conferring effectively absolute resistance, then by the time you've got your new variety, which is resistant, it won't carry the alleles that rendered the parent susceptible. So it actually depends on knowing a little bit about how the resistance arises. Just seemed worth mentioning that.
No, that's very good comment. Thank you. Sorry to be a bit up and down here, but I'm looking up and down this table. Let's see. This is just a comment actually from Bill here that I've picked up. Many varieties with Robagus in their parentage are resistant to yellow rust. Parentage not a good predictor of risk. So I think that probably adds to what Mike was just saying. I'm trying to find some more breeders ones here. It's important to realise that breeders are stacking genes. So although pedigree is important, I would suggest it's more important what resistances have been stacked together. That's from Ron Granger. I think that's a good comment. Another point from Ron, I would suggest you need to remove juvenile yellow rust, as we have found controlling the disease once established is very difficult. and we should not give the yellow rust an opportunity to further mutate. So I think those are two very important contributions. Any comments from the panel on that? The suggestion that we really should be trying to avoid juvenile.
Yeah, I think, sorry, Mike.
Well, no, I was just going to say it's a public spirited thing as well, as Kerry pointed out earlier on. If you've got, even if you've got very effective adult plant resistance, so that the epidemic you've got in your field won't actually cause much yield loss, you don't want to be dispersing clouds of spores to all your neighbouring, all your neighbours, or you'll be unpopular.
Just Adam, in presumably adult plant resistance is usually specific to certain races. It's not impossible that you're looking at a yellow rust in your crop that is a race that is virulent in the adult phase on your crop. So it's a huge chance to take to let it run and assume that the adult plant resistance will kick in. The yield loss that you'd have had by the time you realise that would have been far outweighing the cost of any fungicide.
Okay, I've now got a question from James Brown. It's directed more specifically at Mogans. You said that British varieties have particularly good resistance to yellow rust. Given that wheat breeding is now so international, with several companies having affiliates in many countries, is there evidence that background resistance to yellow rust is also improving elsewhere in Europe?
Well, I don't think I said that yellow rust now, or that resistance in particular in UK varieties were better, but I just showed that the situation for some of the UK varieties supplied by NIAB. But I think in general that European breeders have improved a lot in terms of resistance to yellow rust. I mean, I think that's generally, at least in the Scandinavian countries, we have a lot of good partial resistance towards yellow rust in the wheats, in the winter wheats.
Okay, so several people actually have asked about the origin of the warrior population. I think we commented on that earlier. Is there any further comment on that?
Well, as far as we know, we first detected isolates which were very, very closely related to the warrior race that were first detected in the Himalayas before they came to Europe. So that's the closest we can come, I think. And in fact, I just looked up this. You talked about this isolate 19215. Is that right?
Yeah.
Before, I just checked that. In fact, that's one of the alignment isolates that we got from NIAB this year, and we have put it in the greenhouse. And to us, it looks like just the warrior race, but it may have acquired additional virulence. We don't know, but it looked like the warrior in our hands. The original warrior, but it could well have adapted additional virulence.
Thank you. I've now got a quite academic question. What do we know about gene switching and how this might be triggered with elicitors to bring it forward as such, or indeed the epigenetics of the parent crop? So that's getting into quite a futuristic area. Plant defense activators, presumably. As far as I know, we're not using any in cereals at the moment. Is there anything in the pipeline in that sort of area, Hans, at all?
I'll mute myself. What I'd say is that given the likely regulatory pressures in the EU with the EU Green Deal likely to hit us fairly soon, I think you have to look at non-sidal as well as sidal technologies for controlling disease. So inducing plant defence is one of those that I'm sure industry-wide is being considered more seriously now.
Okay. So, got another question on the, more specifically on the UKCPVS testing system here. The yellow rust reaction in seedling tests Amelia showed on KWS siskin may be classed as not susceptible in the current testing system, but in a field situation, this would trigger fungicide treatment. Is it worth creating a new classification group to accommodate this type of reaction? I think the difficulty in this question is that it really needs to be answered by the UKCPVS folks. So if they want to unmute and someone could talk to that. Amelia, got a comment?
Hi, John. I think that was that the question I answered earlier. When we test the siskin isolates, they are resistant in our tests, but obviously out in the field situation that may be perceived differently. Maybe that's something that we could think of in the future about having some other category for in-field. I think we did have that question for the UKCPVS.
Okay, sorry if I missed that. Maybe can I have a comment in general on this one?
Yes, of course.
I think we should bear in mind that when we do these seedling tests in the greenhouse, we use huge numbers of spores, so it's a very different situation than often we have in the field. So of course the plant is heavily stressed, and all these reactions and is most likely due to this heavy load of inoculum in the greenhouse. So our experience is that when we see such a combination of isolate and variety in the greenhouse, when we take the same variety to the field, it would be resistant in the field.
Thank you. One more on the RL ratings here. Do you think that the RL ratings, this is for yellow rust, should reflect resistance across the whole season rather than just at adult plant stage? It seems to me that we're getting lots and lots of questions on this adult plant issue, which I think we've all agreed is not an easy thing to assess under all circumstances. Any further comments on that?
I wonder if part of the reason we're getting so many questions on this is because of the problems and the environmental conditions that were so conducive last spring. And there's always a tendency to farm by last year. And I do wonder whether the same problems will exist this spring, given how much colder and how much less conducive it's been to date. Clearly the next 3 or 4 weeks may make a difference, but yeah, I'm not sure we need to be worrying about that quite as much as people think. I think if you're dealing with a variety that's got adult plant resistance and there's no clear evidence to suggest that that's likely to change from the UKCPVS data, we're probably in a pretty safe place.
Okay, there's another recommended list question here from John West. Amelia's presentation showed an example of non-race specific resistance, which was cultivar Chabras, which was susceptible to all isolates tested, got less disease in plots. Can that kind of field resistance be quantified for RL lists? Any comments on that anywhere? I think that's possibly one for the future. I mean, that certainly is something that we could discuss at the committee meeting after this. We're always looking at ways to improve the information. So if we can park that one, John. Actually, there's another one here on elicitors, which is Rustwatch has done trials using elicitors to try and control yellow rust, not effective in susceptible varieties, unlikely to replace current chemistry as long as we have it. May have a place in moderately resistant varieties. That's from Bill Clark again. So it's a comment, really, I think. We're beginning to approach the time when we're likely to be finishing. I'm acutely aware of the fact that we haven't gone through all the questions that were on the question pane here, I think is the technical term for it. I apologise to everyone who's actually taken the trouble to write them. We will keep copies of them and see if there's anything further we can do with that. I realise actually for the panellists, they've had relatively little opportunity to comment on their own areas of expertise to some extent. So I'd like to give them another opportunity to raise an issue or pose a question. I've got a very provocative one here actually, which might get you started. Is the goal of a one spray programme for winter wheat a realistic aim? I know we used to discuss this years and years ago. Will there ever come a time when we can get away with a single spray of some magic compound that does the whole thing? Or is it just too ridiculous a notion as to discuss at this point?
Surely that's just an economic question. If the sprays are expensive enough, you'll say, gosh, I can use one and I'll get the first tranche of control you get is always larger than subsequent ones, if you time it optimally. And it's not, you could regulate, there will be only one spray, you'd have slightly less yield, less yield. Some farmers would go out of business, there might be shortages, there might not. But I'm not sure but it's not a scientific question, it's an economic question.
No, well, crop protection involves lots of economics, of course. So
yeah,
I think it's hopefully a provocative question, but maybe one that we can all think about a bit.
I agree with Mike. Sorry. I'd agree with Michael on that entirely. It is entirely an economic question. I guess the question perhaps could be, are there any varieties or situations currently out there at the moment where that's the best economic decision to spray only once? Yeah. And I think there's very few circumstances where that's the case. I think the likes of varieties like X-Days, though I say that with some caution given we're now finding yellow rust on X-Days, but varieties like Theodore, perhaps those that we really haven't seen significant amounts of yellow rust, brown rust, or septoria. And if they're sown in environments not conducive to the disease as well, or in a way that's not conducive, perhaps late in the season, then yes, I think one spray may be achievable, but I think those circumstances are few and far between at the moment.
I think,
yeah,
John,
sorry, carry on, Kerry.
I was just going to say, just to take that in a slightly different way, rather than saying do you head for a single spray, which is a very economic decision, has already been discussed, but we are getting to that point where we're getting some really, really good tools now to work out how much disease you've got in your field, is the disease present. We know a lot more now about yellow rust, for instance, and adult plant juvenile resistance, what resistances a variety has. So maybe we are actually taking a step, perhaps not to a single spray, but to a point where we can actually tailor what we're using and when we're using it far more to the diseases that are actually present, to the modelling which would suggest what's going to be there. But ultimately, we need a crystal ball really to decide what weather conditions we're going to have. So with the best will in the world, you can say, not spray now because it's dry, for instance, but when you do need to spray, you might be faced with 3 or 4 weeks of continuous rain. So unfortunately, that's where our crystal ball really needs to work hard.
No, I think that's a fair comment, obviously. Any other contributions at all?
Well, just to follow up on that, I think it's sorry. Yeah. Well, just to follow up on that, John, I think it's a great point, and I think it's really about ensuring that you get the timing right of that one spray, if that's the spray you're limited to. I think from a technological point of view, either chemical or otherwise, it's very difficult to design a molecule or whatever other control measure you have that will last a whole season. That's not gonna happen,
No.
right? So it's got to be about timing, and that's where some of the sort of diagnostic technologies and the forecasting or predictive technologies that Kerry mentioned really come into their own.
Yeah, very good.
And I might just follow on then, John, and just finally say that from the aspect of it, it's everything there. It's IPM. It's the decision to actually grow the crop at the very start will have all these influences, you know. And that's once you put it in the ground, you're starting that process to the point where actually you make the decision to apply a fungicide or not.
Yeah. Yes, I think to go completely left field from that, I think some oilseed rape growers have already been struggling with that question, whether you grow it in the first place. But thanks very much for those contributions. I guess with that goal of a single spray program, we always came to the conclusion that we'd be stuck with fusarium if we were, you know, really going strong on a single type of treatment, because I guess, you know, it depends how risky the area is whether you have fusarium or not, but timing is so critical with that. It's a really difficult disease to control.
John, you can also build in the IPM component of this also, and that gets back to rotation and all that. So it's all those components are involved.
Yeah, I think that's a very good topic or theme to finish on. I think we're all aspiring to more integrated approaches, but there are obviously states of knowledge problems with some of it. We haven't talked about biologicals. I don't think Mike is going to be contributing on that, are you, Mike? I mean, that was one reason we invited you onto the panel was we thought there might be a question: is there any prospect of biologicals being used in cereal disease control?
Well, there is, because as Hans has mentioned, and the wonderfully named Piriformis spora does appear to give very good control of ear fusarium, not to mention root fusarium, with a single application. Whether that could be made economic, I have no idea. And there are patenting problems and hazards, and all of these things run into biological control. I would love to think you could have a disease, a hyperparasite of rusts, which would manage yellow and brown rusts together, or yellow rust on its own. But the problems of getting it into, the problem is it always chases the disease. So yes, you can kill off the yellow rust once it's present in the field, but that's a little bit late.
No.
So I would not put a lot of money into biologicals of that type at the moment. I think elicitors like the Piriformis spora are more likely to become possible.
Okay. Well, unfortunately, we don't have the crystal ball at this moment. Future technology. I'm going to draw things to a close here because we are actually now at 1:30, which I think is 10 minutes later than we intended to go on to. I thank everybody for their patience if they're still with us. It's always a bit tricky running these question sessions, to be honest, when you get written things appearing and you can't get through all of them. So again, an apology to those who haven't had their questions dealt with. I'd like to thank all of our presenters today for what they've shown us. Obviously, a great deal of work in the survey itself. I also would like to thank our two guest speakers for making the effort to join us, and also the panel members for their contributions. I'm sure there will be many further questions arising from that leading into the future. And I'd like to thank all the participants. I can't see you all. Sorry, it's very weird, this virtual world. But I know there's a lot of people out there, including some good colleagues and friends of mine. So thank you for joining us, and I hope you found the program worthwhile, interesting, thought-provoking. So many thanks, and thank you also to the organisers who've helped to get the technology up and running. I was sort of quite worried at one point the whole thing might collapse halfway through, but actually, touch wood, we've done pretty well, I think. Okay. Thank you and goodbye.
Thanks, John.
Bye bye.
Bye.
Bye-bye. Thank you.
Bye.